Hello students, now we are going to learn complex numbers of class 12th. Complex numbers means points in a plane. So let us see the class 12 maths complex numbers. So complex numbers class 12 maths. Let us understand. We know in quadratic equations b square minus 4ac is greater than 0. We have a real root for that quadratic equation. But if it is less than 0, we don't have root in real equation. That is the need of complex number arised. But it isn't touching x-axis. If it is less than 0 means it is not, there is no root in touching x-axis. But it may be touching y-axis. Suppose you see this curve. It is touching y-axis at 5. It is not touching x. So there is no root for this in the x-axis. So all such points where there is no root in the x-axis, they have root in the y-axis, can be you find out using complex numbers. So this has resulted in expansion of our number system. If you see our number system, see from 1 onwards, this is my natural numbers. From 0 onwards, my whole numbers. Then comes minus. This is my integers. The number system is expanded to integers. Then we have fractional numbers. 1 by 2, 1 by 3, 1 by 4, like that. We have fraction numbers, quotient numbers. Then we have real numbers, that is root 2. What is root 2? Suppose this is 1. This is 1. This value is root of 1 square plus 1 square. This is root 2. So if I put a curve here, if I draw an arc here, the point here, it comes here, 1.414. So this point is root 2. Similarly, we have 1.732, we have root 3. So these are all real numbers. But we don't have any number. Suppose if the number is here, this is origin, if the number is a plus ba. So now we have come from x-axis to a plane system. Earlier, whatever we have defined in this natural, whole, integer, and rational numbers and real numbers, these are all on x-axis. So this is x-axis. Now we are defining a point on containing both x and y-axis in a plane. This is both x and y-axis. So that forms my complex number. Say 5 plus 3i. That means 5 and 3. This is 5, this is 3. This is 5 plus 3i. I means y-axis. What he says I means it is turning by 90 degree. What is meant by I? It is turning by 90 degree vertically. So when I say a plus b, this is a, x-axis is a, y-axis is b, and this point is location is in Cartesian coordinates a comma b. But in complex number, we designate as a plus b I. The need of I will see further, but it can be represented as a comma b in a Cartesian coordinate. Okay, so why it is coming, we will see further. So the complex number is an ordered pair of real numbers. If b is 0, then becomes my x-axis number. Suppose 4, 5. The imaginary part is 0. This is imaginary axis. The imaginary part is 0. So complex number contains all real numbers also. When y is 0, it becomes all real numbers. So that is why the circle of complex number is bigger. You see here another complex number. This ODP is there. It is at a distance of, let us say, x-axis x distance, y-axis y distance, this is y-axis, this is z-axis, z-axis z distance. So this is termed as xi plus yj plus zk. This is a three-dimensional point of a complex number. Xi plus yj plus zk. The three. So now, but our chapter presently contains only two plane, a two dimension, a plane, not a three dimension. But three dimension also the complex number is valid. Like xi plus yi yj. Normally y-axis is j, x-axis is I, z-axis is k. But here we are talking as y-axis as I for the initial. Later on, when it comes to three dimension, we represent this I, this j, and the z-axis as k. It's like a room. In a room, we have a point, three-dimensional point. So this is an extension of complex numbers for the three-dimensional graph. Okay, so we understood the purpose of the complex numbers. So AB says A plus BI. This is an ordered pair of real numbers. B belongs to imaginary axis, A belongs to x-axis, real axis. So this is a real part, this is imaginary part. There is always a 90. You cannot add these two together. They are different. This is like an x, A plus bx. Suppose A plus bx, C plus dx is there. Can you add A and dx? You cannot add A plus C plus B plus D into x. So I is like a x. It is like a linear equation, A plus bx. In place of x, we are putting I. So I and I only can be added. The real and this cannot be added directly because they are representing the vertical axis. They are not in the same line. So the backbone of the system is the imaginary unit. You see here. Suppose x square minus 1 is there. What is this meant as? X plus 1 into x minus 1. It has two roots, plus 1 and minus 1. So plus 1 is one root, minus 1 is another. But if it is x square plus 1, it is not having any root on x-axis. But in y-axis, it is having root. So if I put x is 0, y becomes 1. So this is the x square plus 1. So what is this? When 1 goes the other side, it becomes minus 1. X square is equal to minus 1 and x is equal to plus or minus root of minus 1. So in fact, root of minus 1. So root of minus 1 is nothing but I. I is plus I. This is 1 in the y-axis. I means y-axis. The value, whatever value before I is the value. Suppose BI. B is y-axis. BI. So along the y-axis, it is B. Like that. So it can be written as x plus I into x minus I. This is x square minus I square. As I square is minus 1, it becomes x square plus 1. X square minus I square. Minus or minus 1 is plus 1. So x square plus 1. So here if I put it 0, I'll get plus I or minus I. Both are roots here on the x-axis. I means what? Root on y-axis. 90 degree. I means what? It rotated by 90 degree. I means what? Rotation by 90 degree. So here are some examples of complex numbers. 1 plus I. 1 plus I means what? 1 and 1. Here 1, here 1. This is 1. 1 comma 1 is 1 plus I. 39 plus 3I. 0.8 minus 2.2I. Like that. So minus 2 plus pi I. What is minus 2 plus I? This is minus 2. Here this is minus 2. This is plus pi. Pi means what? 3.14 something. So root 2 plus I by 2. So these are the our Cartesian coordinates. We are representing in terms of complex numbers. See this equation, y is x square plus 4x plus 5. If x is 0, y is equal to 5. So it is touching y-axis at 5. And nowhere, neither it is touching x-axis nor it is touching y-axis. So there is only one root it has in the y-axis. And x is 0. When y is 0, there is no x-axis root. It is 5i. Its root will come 5i. That means same thing. Now let us see. Suppose a complex number 2 plus 2i is there. This is 2 and this is 2. This is 2 plus 2i. What is the angle here? Vertical is 2, horizontal is 2, so 45 degree. 2 by 2 tan theta is 2 by 2, 145 degree. So we'll say the value of this length of this vector is 2 square plus 2 square root of 8. This is called r. And the degree is pi by 4. So we can represent same 2 plus 2i as root 8 comma pi by 4. So this is in polar coordinates. This is in polar coordinates. This is my Cartesian coordinates complex number. 2 is a axis coordinates, and root 8 pi by 4 is my polar coordinate. So this the root 8 pi by 4 is also complex number. So here our root 8 is r, the modulus of this, the length of this r. 2 plus 2 is not 4. 2 plus 2 is not 4. 2 square plus 2 square, and because they are at 90 degree. If the 2 is here, 2 plus 2, 4. So here root of 8 is less than 4. So if it is in second quadrant, we have 135 degree. If it is in third quadrant, we have 225 degree. If it is in fourth quadrant, we have 315 degree. But officially, the argument, what we are calling argument or amplitude of a complex number z is plus within plus pi or within minus pi. Either you can read like this or you can read like this. It cannot have value more than pi. This is the official nomenclature. So this can be written as either 135 or pi minus 45. Both are okay. But this cannot be written as 225. This has to be written as pi minus 45. Pi minus pi plus 45 is written as minus pi plus 45. This has to be written as minus pi plus 45 because the argument is less than pi. Minus r plus r pi. It cannot be more than pi. But this is preferred. We normally prefer this way because we know the plus. This is in third quadrant. We know this is in fourth quadrant. This has to be written as minus theta, minus pi by 4. So this is minus pi by 4. This is minus pi plus pi by 4, or pi by 4 plus pi by 4 plus pi by 4. 3 pi by 4 minus 3 pi by 4. This can be written as minus 3 pi by 4. So like that, we have an argument. We have a value of the ray, the vector value, vectoric value. All cases of root 2 have taken. So root 8 is the length of the arc, and angle with respect to origin is my argument. So my complex number can be represented both the ways. Let us do some addition of complex numbers, some operation on complex. Suppose two complex. I told you I is like x. So a plus bx plus c plus dx. So when I add it, I cannot add a plus d. This is separate. This is a vertical term. This term, 90-degree term. So this can be written x-axis to be added together and y-axis to be added together. So a plus c plus b plus d I. So real parts and divisor to be added. So similarly for minus also, this is to be minus separate. This is to be minus separate. Suppose you have to add this. So 3 plus 4, 7. 5 minus 3, 2. So the answer is 7 plus 2y. You see here, this is 3 plus 5y. X-axis is 3, y-axis is 5. This is 3 plus 5y. Here 4 minus 3i. 4 minus 3i. This blue axis is 4 minus 3i. From here, x-axis is 1, 2, 3, 4. And y-axis is 1, 2, 3. So reduced. Y reduced by 3, x increased by 4. So we have added x to x. x1 plus x2 is 7. y1 minus y2 is 2. So this is my result. And black one is my answer. Otherwise, 4 minus 3, how I have to represent? This is 4. 3 will come here. This is the point. 4 minus 3 point. This is the arrow. So this arrow I have superimposed tail to head to tail here, so that I have done an addition of the vector. Now let us see multiplication of the, this is subtraction of the vector, same, a minus c plus b minus d. This is part of imaginary axis or y axis or I axis. Okay. Now how to do multiplication? Normal, a plus bx into c plus dx. How we multiply? ac plus adx. ac plus adx. bxc plus bdx square. bxc plus bdx square. Simple, a linear multiplication. In place of x, I am putting y. So since we know I square is minus 1, this is how the fundamental definition of I square. This is I square is minus 1. See, if you see here, this is I. So I am further rotating into another I, this I square. So plus axis will become minus axis. If I rotate further I, it will become minus I. So I cubed is minus I. If I rotate further, I to the power of 4, that is equal to 1. So minus 1 into minus 1, that is plus 1. So with respect to I, each I am rotating my axis. I 90 degree, I square minus x, I cubed minus I to the power of 4 plus 1. Again cycle repeats. So every I to the power of 4 is, again we are coming back to x, positive x axis. I, we are going to y axis, I square, negative x axis, I cubed minus y axis. This we have to understand concept. The same thing is applied here. When I square means this is going to minus axis. So AC minus BD plus I into AD plus AC. This is how we multiply. You see here, 3 ones are 3, 3 sevens are 21I, 2 ones are 2I, 2 sevens are 14I square. So this will become minus. So minus 11 plus 23I is the answer. Let us see some more examples on I. Suppose what is square root of minus 9? Root of minus 9 can be given as root of 9 into minus 1. So root of minus 1 is my I. I square is minus 1. Root of minus 1 is I. So this is 3I. 3I. You can write it as plus or minus 3I. In that case also 9I square. 9I square means minus 9. Here also 5I. You can write it as plus or minus 5I also. It has plus or minus 5I. If I multiply it, what is happening? 25I square. Minus also 25I square. So minus 25. It coming to same. So this here minus 18. 18 minus means I. Root of 18. 18 means 9 2s are. So 3 root 2. This is simplify square root of root of minus 6. So minus 6 is minus 6. Minus root of minus 6 is minus I. So minus I root 6. Minus root 6 I or I root. Because this I is out of the bracket. Minus I root 6. So it's only to understand how I is behaving. Let us see here. 2I plus 3I simply 5I. Like x, I told you it is like an x. 2x plus 3x is how much? 5x. This is 11x. Multiply 12I square. I square is minus 1 minus 2. What is I square? I told you minus x axis. That is minus 1. Multiply and simplify this. So 2 3s are 6. I square is minus into minus plus I. So it is 6I. So by seeing itself, we should be able to understand I. So that we can attempt more complicated problems in the coming chapter. Now let us understand the powers of I. I to the power of 1 I square I told you minus x axis minus 1. I cubed is minus I because minus y axis. I to the power of 4 is again plus 1 plus x axis. So these are all further multiples of this. From I0 of I means I can remove I0 of 4. So it is y-axis. It is minus I, x-axis. This is minus y-axis. This is again x-axis. So in terms of I0 of 4, I can see where it's coming I minus I plus 1 minus 1. So with I0 of 17. So I0 of up to I0 of 16 it is plus 1. So it becomes I. I0 of 120 it is simply 1. Because it's divisible by 4, so it is simply 1. I0 of 60 is 1002, so I square is minus 1. Simple. So we have to see how this to the power of 4 means it is coming back to x-axis. So we have to reduce it, I to the power of 4 into something into I to the power of square. So this is minus 1. So let us see the some properties of complex numbers. Suppose Z1, we can complex number A plus B can be called as Z. So this is a function. This is basically a function. A plus B. So A plus B, it can be X plus IY, like that. So X plus A plus B, A1 plus B1, A2 plus B2. So when I add Z1 plus Z2, just to have seen properties of addition, A1 plus A2 plus I into B1 plus B2. Suppose if I add Z2 plus Z1, it will remain same. So that is why it is commutative. Z1 plus Z2 is equal to Z2 plus Z1. Similarly, whether it is associative, yes, this I can add Z2 plus Z3 first and Z1, or I can change the sequence. Whatever it may be, the terms will be added. The real terms will be added separately, and the imaginary terms will be added separately. So additive identity means Z plus 0 is Z. So if I add 0 to this, so 0 plus 0i, A1 plus 0 plus 0i, A1 plus 0 is A1, B1 plus 0i is B1. So this is Z1 itself. This additive identity is 0. And what is additive inverse? Additive inverse. Minus Z is additive inverse. Suppose minus Z means minus A1 minus IB1. If I add Z1 minus Z1 plus of minus Z1 minus A1 minus IB1, it is 0. So minus Z is additive inverse. Now let us see the multiplication properties of complex numbers. This is Z1, this is Z2, this is Z3. So again we have, they are commutative. Z1, Z2 is equal to Z2, Z1. We have seen here. This is a multiplication. Whatever, it is like an X. 3 plus 2x, 1 plus 7x. I can multiply 1 plus 7x into 3 plus 2. It's all the same. So simply assume this as X. That means it all properties of our quadratic equations do apply here. So this is commutative. What is associative? I can rearrange the terms in multiplication. Z1, Z2 I can first multiply, then I can multiply Z3 or Z2, Z3 and Z1. What is multiplicative identity? 1, 0. If we multiply this with 1, 0, what will happen? A1 plus IB1 into 1 plus 0i. So A1 into 1, A1 plus IB1 into 1, IB1, 0 and everything is 0. So this becomes Z1 itself. So this is multiplicative identity. This is additive identity is 0, multiplicative identity is 1, 0. What is 1, 0 means what? This point. This point for every, this is a multiplicative identity. This is again distributive. This again distributive. Z1, Z2 plus Z2, Z1, Z3. Less like a linear equation, all are applicable in this also. Now let us understand what is a conjugate of a complex. Because most of we need conjugate when we do division. When we go in the division process, we need conjugate. See, this is X plus IY, this is X, this is Y, this is X plus IY. You draw a mirror image. Let us assume X-axis as a mirror. So you get an image here at a distance of minus Y. So this is plus X minus IY. This is a conjugate of Z. We can represent as Z bar. Z bar. So here I have somewhere I have represented Z dash also. because the bar provision is not there. So, but both are complex number, conjugate of existing complex number. So, what is minus z? Suppose I want minus z. So this goes here, this way. Minus x, minus y. This is minus z. Arrow extends into the other direction. This is a vector. OZ is a vector. In fact, basically, this topic has come in the initial stages where people, vector also they don't know. Nowadays, we know vectors, we have done commutative geometry, we have done a lot of lines, circles, so we know 2-dimensional, we know sometimes 3-dimensional also. But those times, people do not know even vector concept. So, this is vector, negative vector, this is minus z, this is z bar. So, difference between z bar and minus z is both are minus x and minus iy. Z bar is conjugate. Only y-axis is a mirror image. Suppose 2 plus I is there. What is the conjugate? 2 minus I. Minus 3 plus 7i. Minus 3 minus 7i. So minus 3 will not change. X remains. So minus 3 plus 7. This is minus 3. Let us assume. This is 7i. So this is a mirror image. It will come here. So minus 1 is plus. So 6 minus 4i. Come to 6 plus 4i. Why you need conjugate? Because when I multiply this, I will get a real number. When I multiply both conjugate, what I will get? This and this, when I multiply theta plus minus theta, it will become 0. So I am getting a real number. When I multiply two conjugate numbers, it will become a resultant one on the x-axis. So real number. There is no y-axis. They get cancelled out. Y get cancelled out when I multiply. When I add also, y is getting cancelled out. When I add, what is happening? 2x, it will become 2x. And I'm multiplying also, y get cancelled. So let us see. So I want 1 by a plus ib or jb. In place of I, it is written as z because y-axis normally we term as z. But here, okay, let us see. So I am putting a conjugate on both sides, of denominator and numerator. So a plus x plus y into x minus y is x square minus y square. So this is becoming a square minus j square b square. J square is minus 1, so it becomes a square plus b square. So a minus jb by a square plus b square. So 1 minus a plus d is nothing but a by a square plus b square minus j into b by a square b square. So we got a from division, I from the division has come to numerator. This is my complex number. So 1 by a plus jb can be represented as a by a square plus b square minus j by b square, a square plus b square. This is nothing but a by a square plus b square means unit. This is unit value of the vector. B by a square plus square is a unit value. So this is a unit vector on the top axis. Let us see another example. So 2 plus 4i I am multiplying both sides. So 2 square minus 4 square I square is plus. So 2 square plus 4 square. So top is normal multiplication a plus bi into c plus di. So 5 2s are 10, 5 4s are 20i, 3 2s are 6i. So is 12i square. 12i square is minus 12. So it is becoming minus 2 plus 26i by 20. This is simplification form. Okay. So now you understood how to bring this is unnecessarily problem. Okay. Now let us say this problem. Same thing. So this is what? A plus b into a minus b. So I have done conjugate here, both sides. So this is a square minus b square in the bottom. So this is not minus 3 whole square is 9. I whole square is I square. I square is minus 1. So it becomes 1 by 10. So top we had a normal multiplication of a plus bx into c plus dx. So when I simplify, I square is minus 1, 4i square become minus 4. So I am getting minus 25 minus 5 by 10. This is I. So when I take out 5 here, so minus 5 minus I by 2 is the simplified form of 7 plus 4i by minus 3 minus I. So this has become minus 5 minus, both are same. So if I had to represent this on my complex number on my geometry, I have to put minus 5 by 2 minus I by 2. So here minus 5 by 2 minus 1 by 2 I. This is the point. This is the vector of this portion. So I have simplified it by using conjugate. That is why we need conjugate of a complex number. Let us see. This is how the division process has arrived. Let C is equal to AC plus BD by C square plus D square. So this is a derivation. Let C be AC plus BD by A square, D square, C square plus D square plus I BC minus AD by C square plus D square. So I am multiplying B is C plus ID, A is A plus IB. So when I am multiplying B into C such that it becomes A. When I am multiplying B into C, B is C plus ID, C is this one, this real portion, this imaginary portion, AC plus BD by C square plus D square plus BC minus AD by C square D square I. So when I am multiplying these two, I am getting A plus IB into C square plus D square is a numerator. So denominator gets cancelled, C square plus D square is the denominator. These two get cancelled, this becomes A plus IB. Basically what we have done here, we have assumed a C which is equal to AC plus BD by C square plus D square. A is A plus BI, B is C plus DI. So this C, basically it has come up by using a conjugate of B. In place of C plus DI, I am putting C minus DI. So I am putting the bottom C square plus D square. So A into C minus DI. A into C minus DI. When I multiply this, I am getting AC plus BD plus I into BC minus AD. So this is the examples we have done to understand this concept. So basically it's the conjugate multiplication, numerator and denominator. But in place of this, there is a formula. This is difficult to understand this, difficult to by heart this. So it is better we approach through conjugate method only instead of by hearting this. This is nothing but C into conjugate of B, A into conjugate of B is C by C square plus D square. Okay. Now, if A is A plus IB, then what is A inverse? A inverse means 1 by A plus IB, can be written as A minus IB by A square plus B square. So A by A square plus B square minus B by A square plus B square is A inverse. This is called multiplicative inverse of A, because A dash is 1 0. What is multiplicative inverse of A? 1 by A dash. So both sides I am putting A square minus I square B square in the denominator. So A square plus B square in the denominator. So numerator will get A minus IB. So A by A square plus B square. This is the multiplicative inverse. Whenever we are asked to find multiplicative inverse, we can use this formula. Basically, I am putting 1 by A minus IB. Multiplicative inverse of minus 2 1 sin A cos A 7 2 4. These three we have to find multiplicative inverse. What is A square plus B square here? 2 square is 4 plus 1 5. So A by A square plus B square. So minus 2 by 5 minus B by A square plus minus 1 by 5. So this is the multiplicative inverse of this. Similarly here, sin square A plus cos square A is 1. So we have sin A minus cos A. Here we have 7 square plus 24 square is 525. So 7 by 525 minus 24. So basically I am writing the conjugate of this. 1 by inverse is nothing but conjugate of divided by A square plus B square. Basically what I am doing here, by a square b square means I am making it a unit vector. I am making it a unit vector into conjugate. Here, this conjugate converted into a unit vector by a square plus b square, by x square plus y square. So when I am multiplying this is becoming my multiplicative inverse. I have done 3 examples here. Let us see here. This is x plus iy. So we have to simplify this in terms of x plus iy. So I put 2 plus I on both sides, 2 plus I bottom and 2 plus I bottom. So this is 4 minus I square means 5. So top I have simply square. This I square is minus 1. This is getting cancelled. So 2i. 2i into 2 plus I. This is again 2i square become minus 2. So 4a minus 2 by 4 plus 1, 5. So these are shifted into 2 individual terms. Minus 2 by 5 plus 4a by 5. So what is x? X is equal to minus 2 by 5. What is y? Y is equal to 4 by 5. So when I add x plus y, I am getting 2 by 5. So what is this problem is asking? You have to simplify into a smallest form. Is the small real term and imaginary term. There is no division of I. There is no multiplication of I. All are simplified. We converted this into x plus iy. Similarly here, so first I have to convert this into x plus iy. So 1 minus I by 1 plus I can be written as I am doing conjugate of both. Multiplying 1 plus I minus 1 by 1 minus I square. That means 2 in the bottom. Bottom is 1 minus I whole square. 1 plus I square minus 2i. So it becomes minus 2i by 2. 2 get cancelled. Minus I to the power of 100. 100 means I to the power of 4. So that means 1. So this can be simplified. First you have to simplify using conjugate. Then you have to see the root 100 is nothing but 1. Same thing, another problem. Again, I use a conjugate here. 5 plus 3, 5 minus 3, 5 plus 3 is 25 minus 9i square. So plus 9. 25 plus 9 is 34 in the bottom. So these two multiplication. 4 5s are 20. 4 3s are 12. 2 5s are 10i. 6i square. 6i square is nothing but minus 6. So 20 minus 6 is 14. 12 plus 10 is 22i. So when I simplify, this is my x plus iy format. Here also. So 5 plus I root 3 by 1 minus I root 3. So I have to multiply 1 plus I root 3 both. So this becomes 1 minus b square is 3. A square minus 3i square. That is 1 plus 3, 4 in the bottom. This is the top. I have to multiply these two. 5 ones are 5. Root 3 into root 3. 3i square is minus 3. So 5 root 3i plus 1 root 3i is 6 root 3i. This is my simplified form. This is what just is the conjugate of that. This is plus, conjugate is minus. Let us see on the conjugate itself. Z1 plus Z2 bar is equal to Z1 bar plus Z2 bar. So I am putting Z1 plus Z2. So I have converted all plus here, I terms here, bar means minus. So again, real terms and imaginary terms are separated like terms of Z and Z. So it becomes Z1 bar plus Z2 bar. Similarly, in minus also, this is applicable. So Z1, Z2, Z1 bar into Z2 bar is equal to Z1 bar into Z2 bar. Let us see. I am multiplying A plus IB into C plus ID. Z1, Z2. So what I am getting? AC minus, because BD into I square. I square is minus. So AC minus BD plus I into AD plus CB. This can be written as AC plus the conjugate of this what? Becomes minus is the conjugate. So what is this one? This is Z1, Z2 bar. This is Z1, Z2 bar. Now I have rearranged items. I found it is nothing but Z1 bar into Z2 bar. This is Z1 bar. This is Z2 bar. So this is Z1 bar, Z2 bar. So Z1, Z2 bar is equal to Z1 bar, Z2 bar. Similarly, Z1 by Z2 bar is equal to Z1 bar by Z2 bar. So all such things we can prove from the fundamentals. What is fundamental? Fundamentally assume Z1 is A plus IB, Z2 is C plus I. So assuming the fundamental, we can prove all are same. Okay. Now let us see square root of a complex number. How to find out a square root of a complex number? Let x plus I whole square is a plus ib. Then what is square root of a plus ib? Is x plus ib. So to find the square root of a plus ib, I am assuming some x plus ib whole square is a plus. Similarly for cube root also, I am assuming x plus a plus ib is equal to x plus ib whole cube. So when I expand left hand side, x square plus I square y square. So this is x square minus y square. This is the real term of this, which is equal to a. What is the imaginary term? 2xy into I is equal to b. So we have x square minus y square is a, 2xy is equal to b. From these two terms, I am finding what is x square plus y square whole square? A minus b whole square plus 4ab. So I am getting this as root of a square plus b square. What is x square minus y square is a? So this becomes a square. What is 2xy is b? What is 4x square y square is b square. So a square plus b square is equal to x square plus y square whole square. So if I remove this square, I am getting x square plus y square is root of a square plus b square. X square minus y square is a, from which we get solve x and y. This is the solving of x and y. When I add, I get 2x square is equal to a plus square root of a square plus b square, and of, so root becomes under root. So it is difficult to remember this formula. It is easy to limit our exercise up to this point. So we should know when we have to find out a square a plus ib root, it is x plus ib such that x square minus y square is a, x square plus y square is root of a square plus b square. This is nothing but r. What is root of a square plus b square? This is modulus of this. So x square plus y square is modulus, and x square minus y square is real part. You see what is root of a square plus b square? This is root of a square plus b square. This is nothing but modulus. So x square plus y square is this one, and x square minus y square is a. This is the square root application. So we have done this from fundamentals. Always fundamentals a plus ib is x plus iy whole square. So x square minus y square is a, x square plus y square is root of a square plus. Let us remember these two terms and we can solve all the square roots. Here one thing is important. If b is plus, then both on xy are plus. If b is minus, they have opposite sign. This is how to remember. So suppose if it is a minus ib, if it is b is less than 1, x minus iy, so then we'll write it as x minus ib. A minus ib root square root is x minus ib. A plus ib square root is x plus ib plus r minus. So this has to be remembered. Because the slope is same, y by x, y by x. Let us find out what is root of minus 416 is 4i. Root of 18 we have already done. Root of minus 9 into root of minus 4. So this is I into I square is minus 3 into 2 is 6. So what is root of I? We have been asked what is root of I. Let it be a plus ib. So I am squaring both sides. This become I is equal to a square minus b square plus 2abi. So again we are comparing real and imaginary terms. A square minus b square is 0 and 2ab is equal to 1. From which I will get a square plus b square is equal to plus 4a square b square. That means 1 square, that is 1. So when I solve a square plus b square is equal to plus or minus 1, a square minus b square is equal to 0. I am getting 1 by root 2. 1 by root 2. So the answer is 1 by root 2 plus I of 1 by root 2. If I do square of this, I'll get same as root I. 1 by root 2 square plus 1 by root 2 square is 1 by 2 square plus 1 by 2. That is 1 plus 2ab. 2 into 1 by root 2 into 1 by root 2. 2 to get cancelled plus I. So this is b square is minus 1 by 2. They get cancelled. 1 by 2 minus 1 by 2 getting cancelled, and 2ab is I. Automatically I am getting. Let us see some more textbook examples. What is to simplify this to 2n plus 1 terms? Just observe. I to the power of 4 is minus I square. I to the power of 4 is minus I square. So these two get cancelled. Again, I to the power of 8 is minus I to the power of 6. So I to the power of 4 can be written as I to the power of n can be written as I to the power of n minus 2 into I square. So I to the power of n minus 2, I square is minus 1. So minus I to the power of n minus 2. So alternate terms get cancelled. So this is odd term. So n plus 1 is an odd term. So this will be left out. So I square whole to the power of 2n plus 1 is left out. So this is nothing but I to the power of 2n into I square. I to the power of 4n is 1. So I square is minus 1. So simplifying, I am getting minus 1. This is the only term left out. I to the power of 2n plus 1 is, what's the first term? N is 1. First term is 2. What is the second term? 4. I to the power of 4. Third term, I to the power of 6. Like that we have 2n plus 1 terms. So first term is I square whole to the power of 1. Second time, I square whole to the power of 2. Third term, I square whole to the power of 3. Similarly, 2n plus 1 term, I square whole to the power of 2n plus 1. So when I simplify, I am getting minus 1. Let us see square root of this. Then we know a square plus b square is equal to root of a square plus b square, and a square minus y square is a. So when I substitute here, adding 2x square is equal to a plus square root of a square plus b square. So x is equal to plus or minus 1. Similarly, y is equal to plus or minus 3. When I minus, I'll get 2y square. So root of a square plus b square minus a. So plus or minus 3. So square root of this is, it is given what? It is minus. B is minus. So I'll get x minus iy. So plus or minus 1 minus 3i. So let us cross check this. 1 minus 3i whole square. So 1 into 1, 1. 9i square is minus 8, minus 9. So 1 minus 9 is minus 8 plus minus 6i. So this is tallying with my given complex number. So if I put plus 3i, 1 plus 3i whole square, I am getting minus 8 plus 6i, which is not correct. So since b is less than 0, I have to put minus here. Of course, plus or minus valid. So understood this? Let us see this one. What is multiplicative inverse? We know the formula. A by root of a square plus b square. B by root of a minus b by root of a square plus b square. So root 5 by a square plus b square is 5 plus 9, 14. So root 5 by 14 minus 3 by 14. Or we can do this into x plus iy is equal to 1. So I can solve for x and y here. Otherwise, we have formula a by square root of a square plus square minus ib by square root of a square plus b square is the conjugate of my multiplicative inverse. Here we have done multiplicative inverse problems. These are multiplicative inverse problems we have done here. We have used a by a square plus b square minus b by a square plus a square. So what is the multiplicative inverse of I to the power of minus 35? So I to the power of minus 35 can be written as I to the power of minus 36 into I. So this is 1. So this is I. So multiplicative inverse of I is minus I. So I into minus I is equal to minus I square, that is plus 1. So conjugate, basically conjugate. Similarly, if x plus iy is this, then prove this one. So we have given x plus iy, this we have to bring to numerator. So 2 plus cos a minus I sin a, I multiply both sides. So this is a square minus b square. So minus I square will become plus. So 2 plus cos a whole square plus I square in the denominator. So if I calculate this with my x plus iy, x is the real part of that and y is the imaginary part of that. So when I put x square plus y square, this whole square plus y square. So denominator remaining same, square. So I am simplifying this. I am getting 9 by 5 plus 4 cos a. Getting 9 plus 4, 9 by 5 plus 4 cos a. Similarly, when I simplify 4x minus 3 also, I will be getting 9 by 5 plus 4 cos a. Both are same. So both sides are brought. Here I have brought to some extent. 4x minus 3 is brought to both made equal. Let us see. If u plus iv is this, find uv. Again, I have to simplify. X plus 3 minus iy, I have to multiply top and bottom. So this is a square plus b square. So when I simplified it, I got u is the real part of this and v is the imaginary part of this. Suppose z is this. What is z cubed, z square, 58, z simple? We have to simplify this equation. So one way is I simply do 3 times multiplication of z 3 times, then z square into 10, then z into 58, then add all the things. Or is there any other way can I simplify? So if I put z minus 3, my z cubed will be simple. So this I am converting into z minus 3 whole cube. First I have written z minus 3 whole cube. So a cubed minus b cubed plus 3a square b minus 3a square b plus 3ab square. So when I simplify it, I get z minus 3 whole cube plus 3ab square. I simplify these terms. So z minus 10 whole square plus 11z minus 9. So now we put z3. So my cubic fraction will be simplified. So z minus 10 is 3 minus 5i minus 10. So minus 5i minus. So 3 minus 10 is minus 7 whole square plus 11z minus 9. 11 into 3 minus 5i minus 9. So this is now it has become my simplified exercise. I cubed is I minus I square is minus 1. I is of course same I. So what I am getting finally, I am getting 0. 125 they are getting cancelled. 70 plus 55 is 125 getting cancelled. The 25 minus 49 is 30 minus 9. 49, 9, 58. 33, 25, 58. They are getting cancelled. So we have to see how I can simplify my cubic form. So I can add some minus many times, no problem. So this is where this is we have to simplify. Now show that 2 minus I by 1 minus 2i whole square is to a conjugate. That means I have to see this minus 2 plus 11i by 25. I have to simplify this. So this is the first I'm expanding. Then 4i square is minus 4. So it's equal to minus 3 minus 4i. Then I'm using conjugate. Minus 3. I should multiply it with the plus 4i here. Plus 4i. So when I simplify it, I'm getting 1 by 25 minus 2 plus 11i, which is nothing but a conjugate of this. So we have to simplify using conjugate method. So if to the power of 1 by 3 is a minus ib, we have to show this. So I'm cubing both sides. X minus iy is equal to, when I do a minus ib whole cube, a minus b whole cube, a cube b plus b cube plus 3a square b plus 3ab square. Here b is minus ib. So when I'm simplifying and converting to my x and y form, this given is x and I get x and y. So a coming this side, x by a plus y by b is, this is the simplified form. When I simply realize the terms, I'm getting 4 into a square minus b square. So here what I have done, I have simply rough method, simply expanded. Now this one. If 1 plus I into x minus 2i by, or 3 plus I plus 2 minus 3i into y by plus I by 3 minus I is I, find x. This total is a z. So I have to convert it into x plus iy. So I am simplifying. Now I am taking LCM. Here bottom 3 plus I, here bottom 3 minus I. So 3 square minus I square is 4. 3 square minus I square is 4. So I am getting 3 square is 9, I square is 1, 3 square minus I square is 1 by 10. So my denominator I got 1 by 10. So my numerator I have to multiply this with 3 minus I, and I have to multiply the other one with 3 plus I. When I am simplifying this, I am getting a real term and an imaginary term. So finally what I got, by simplifying real term, and when I equate, I get through two equations. 4x plus 9y is equal to 3, 2x minus 7y is equal to 30. When I solve these two equations, because x and both I portion we have x and y, both real portion we have x and y. So when I solve this equation, I'm getting x is 3, y is minus 1 is equal to I. So the real portion is 1, the imaginary portion is 1, and real portion is 0. So here is 1. 1 means here 1 by 10 is there in the denominator. So this 10 has come to the other side. So 10 into 1, 10. Here real portion is 0. 10 into 0 is 0. So let us see another problem from this last problem of this exercise. Find the least positive integer satisfying 1 plus I by 1 minus I whole to the power of n is 1. So I am simplifying these two. So 1 plus I, 1 plus I, 1 minus I square is equal to by 2. I am multiplying both 1 plus I in top and bottom. So bottom becomes 1 minus I square, that is 1 plus 1, 2. 1 plus I whole square is 2i. So 2 getting cancelled I. So I to the power of n is 1. So I to the power of 4, I to the power of 8, I to the power of 16, all are 1. So what is asked is least number. So the n is 4. If find the real values of a if it is real. So I have simplified it 1 plus 2 sin a, 1 plus 2i sin a. I am multiplying both bottom and top bottom. So a square plus minus b square. So 1 plus 4 sin square here. So when I simplify the top one, I am getting, so if the only real part is there, it has only real part, that means imaginary part is 0, I portion is 0. So that means 2 sin a plus 8 sin a is 0. Sin a is 0. That means a can be 0, pi, 2 pi, 3 pi, all pi's. So n pi, n start from 0 to infinity. So n is an integer. Similarly, if it says only imaginary part is there, so the real part is 0. Then 3 minus 4 sin squared a is 0. So that means sin a is plus or minus root 3 by 2. So plus or minus root 3 by 2 means all four quadrants are allowed. Pi by 3, 60 degree, all four quadrants are allowed. So this we generalize term as 2n pi plus or minus pi by 3. N is an integer. If n is 0, then it will become plus or minus pi by 3, first and fourth quadrant. If n is 1, I am getting 2 pi plus or minus pi by 3. Integrate n pi plus pi by 3. If n is 0, I am getting plus or minus pi by 3. Okay. If n is 1, pi plus pi by 3, pi minus pi by 3. Both are okay. So is n plus n is integer. All four quadrants are allowed here. Let us continue complex numbers. So far what we have covered? We have covered the xy form of complex number, Cartesian system, and x plus iy is a complex number. X coordinate, y is the y coordinate. The point is having x, y indices. So x plus iy is a complex number. We also read how to have a conjugate of a complex number, and with the help of conjugate x minus iy, we have learned how to divide a complex number. So division by complex number, division of complex number. So and we understood how to find out square roots of complex. If x plus iy is having a square root, that means x plus iy is equal to a plus ib whole square. So we have found out the real part and imaginary part, and we found out the square root of a complex number. So before going further on complex number problems, let us understand geometrically in a polar coordinates also how this complex number is behaving. Okay. Let us see. We know this point z is a complex number with x coordinate x, y coordinate y. It is xy. So we treat it as x plus iy. The same thing can be represented in the name of xy, or it can be represented in the name of r and this theta. R and theta. This is the distance of the point from the origin, or and the ray making the angle with x in a anti-clockwise direction. Theta. So this r we call it as modulus. What we call it as r as modulus of z. Modulus of z. What is r? We know Pythagoras, x square plus y square is r square. So r is root of x square plus y square. So this is the modulus of this complex number. And this is the theta. So then what is x is called? X is r cos theta. What is y? Y is r sin theta. So x plus iy becomes r cos theta plus I r sin theta. So when I take out r common, cos theta plus I sin theta. So cos theta plus I sin theta gives my unit vector in this direction. When this unit vector is multiplied by r, the absolute modulus value of this z, I am getting a total z vector. So cos theta plus I sin theta is unit vector. Theta can be anything. It can be first quadrant, second quadrant, anything. So this is the unit vector of the system, and this is the absolute value. So unit vector we call it as argument. Theta we call it as argument, or we call it as amplitude. Both. Amplitude is not r. Please remember here. This is a confusing word used here. Amplitude means theta. Pi by 4, pi, that is amplitude. R is modulus. So normally amplitude is represents by distance. The amplitude of vibration, amplitude of system is a distance. But here in complex number point of view, we know amplitude means theta. Pi by 2, pi by 4, pi by like that. So the amplitude or argument is same. They vary from minus pi to plus pi. So this is plus pi. If the ray is along minus x-axis, I can write it as plus pi is argument, or I can write it as minus pi. So it is not more than pi. So if it is in third quadrant, I cannot write it pi plus some pi by 3. No, it has to be written minus 2 pi by 3, minus 3 pi by 4, like that. So in between minus pi to plus pi is its range. So now sine theta is y by r, cos theta is x by r. So what is tan theta? Tan theta is y by x. So the theta, if we are having a complex number in x plus iy, I can say theta is equal to tan inverse y by x. Theta is equal to tan inverse y by x is my argument or amplitude. Y by x gives me tan theta. Simple to understand this. Let us say there is x and y coordinate, Cartesian coordinate, -1 minus I root 3. Here is y is what? Minus root 3. X is what? 1. So my tan theta is equal to, it is tan theta. Okay. R cos theta is -1. R sin theta is minus root 3. R is what? R is root of a square plus b square, x square plus y square. So 1 plus 3, 4, root 4 is 2. It is always plus. Can this distance be minus? R is always plus. R square plus x square is always plus. In this also, minus x whole square minus y whole square is plus. It becomes an absolute value. It is a modulus. Mod. Modulus means mod. There is no minus here. It is all only. So we cannot write plus or minus 2. It has to be plus 2. So r cos theta, r sin theta is minus root 3. The 2 is not there. So theta is in the third quadrant. Sin theta is minus root 3 by 2. So we got r. Here r cos theta is -1, r sin theta is minus root 3. So cos theta is -1 by 2, sin theta is minus root 3 by 2. Here both are negative. Sin theta is negative, cos theta is negative. That means this is in third quadrant. Third quadrant, so it is minus 2 pi by 3. So we will write it as 2 cos minus 2 pi by 3 plus 2 sin minus 2 pi by 3. This is 2 is r, this is cos theta, sin theta. So -1 minus I root 3 can be written as 2 cos minus 2 pi, the cos of minus theta is cos theta, 2 cos 2 pi by 3 minus 2 sin 2 pi by 3. Here minus, this also minus. So these are the tan inverse arguments. If it is in first quadrant, y is plus, x is plus, so y by x. In the second quadrant, y is plus, x is minus, so we write it as pi minus tan inverse y by x. Pi minus tan inverse y by x. This is the quadrant. This is the argument. Let us see here. This is the second quadrant. What is argument here? This is theta is the argument. Theta is the argument. But this is y by x is 45. So what is it here argument? Pi minus this tan inverse y by x. This total is pi minus tan inverse y by x. So I will get my argument. Here what? Minus pi plus tan inverse y by x. Third quadrant, minus pi plus tan inverse. It can be written pi plus tan inverse y by x also, but it is better minus pi, the range is minus pi to pi. So minus pi plus tan inverse y by x. This is minus tan inverse y by x. This is the fourth quadrant. Let us see now. So second quadrant, pi minus tan inverse y by x. Third quadrant, minus pi plus tan inverse y by x. Fourth quadrant, minus tan inverse y by x. So tan inverse y by x is my theta. So with this theta, first quadrant, second quadrant, third quadrant, fourth quadrant. So we should do more practice here so that we can understand immediately in which quadrant and what is its argument. Okay. Before going to this mod of Z1, Z2, org of Z1, Z2, we'll see some examples and come back to this. So let us understand. Cos theta plus I sin theta, we write it as cis theta in a short form. C for cos, S for sin, I sin. So cos plus I sin theta. Cos theta plus I sin theta. So cis theta. So now cos theta plus I sin theta into cos theta plus I multiplied 2 times. So what is becoming? Here I am putting minus. Okay, I have to put minus here. So A plus B, here also minus. A plus B into A minus B, A square minus B square, cos square theta minus I square sin square theta, minus I square is plus 1, so that becomes 1. So cos theta minus I sin theta is equal to 1 by cos theta plus I sin theta. So that means cis minus theta is equal to 1 by cis theta. Cis minus theta is equal to 1 by cis theta. So if I write sin theta plus cos theta, I cos theta, instead of cos theta plus I sin theta, it is sin theta plus I cos theta. So theta is pi by 2 minus theta. So I'll write it as cis pi by 2 minus theta. So cos 90 minus theta is sin theta plus I sin 90 minus theta is cos theta. So this is the difference. Cis theta and cis 90 minus theta, they get interchanged. Understood? So we should be familiar with terminology. Cis theta is what? Cos theta plus I sin theta. What is cis minus theta? Theta minus cos of minus theta plus I sin of minus theta. So minus sin theta. Cos theta minus I sin theta. So we know their multiplication is 1. So it is inverse of that. Now let us understand in terms of e to the power of x. E to the power of x is defined as 1 plus x plus x square by 2 factorial, x cubed by 3 factorial. This was learned in the exponential series. So in case of x, if I put ix, it is power of ix. So wherever x is there, I am putting ix. I square is minus 1. This is I square, this is minus 1. This is I cube, becomes I minus I. I to the power of 4 becomes plus 1. So this repeats, the signature repeats. I minus plus minus I plus. So 1 plus ix minus x square by 2 minus I x cubed by 3 plus x to the power of 4 by 4 factorial. Like that, the expansion repeats. So when I make together terms, I terms and real terms, this is a real term. 1 minus x square by 2, x to the power of 4, x to the power of 6, x to the power of 8. These are the real terms. X cubed by 3, x to the power of 5. These are the my I terms. This is the expansion of cos theta. If I write cos x, if I do my cos x expansion, cos x is nothing, how it is defined as 1 minus x square by 2 factorial, x to the power of 4 by 4 factorial, minus 6 by 6 factorial. It is sin x defined. So cos theta plus I sin theta. Cos x plus I sin x. So that means what? Cis theta can be written as I to the power of e to the power of I theta. Cis x can be written as e to the power of ix. So e to the power of iz is ix is cos x plus I sin x. Both are same. Is only to understand. E is Euler's formula. Euler, the geometry is based on Euler's system. Log E, logarithm table based on U, E. Sin theta, cos theta, they are all functions of E. So you understood here? Now let us see using this e to the power concept. Suppose R1 cos phi 1 plus I sin phi 1 into R2 cos phi 2 plus I sin phi 2. These are two rays, two vectors. I am multiplying two vectors. If we take in terms of EIX, so R1, R2, so e to the power of x into e to the power of x2, e to the power of I plus I. So e to the power of I into phi 1 plus phi 2. Again division, they are minus. They are minus. Let us see here in terms of coordinates z1 by z2. So what is z1? R cos theta 1 plus I sin theta 1. What is Z2? R2 cos theta 2 plus I sin theta 2. So I put R1 by R2 separately. So I take, I know how to divide. Conjugate, I am taking conjugate both sides. So bottom became 1, cos square theta plus sin square theta became 1. Forget about this. What is it? Top we are getting cos A cos B plus sin A sin B. This is cos A minus B plus I sin A cos B plus minus. It should come minus here. It is minus. Sin A minus cos A sin B. Sin A minus B. Because sin theta 1 cos theta 2. So that plus minus sin theta 2 cos theta 1. This is minus here. So sin. So what we got? Theta 1 minus theta 2. R1 by R2 is theta 1 minus theta 2. This is my polar coordinates which I have converted. Same thing if it is here, e to the power of I theta 1 minus theta 2. So cos theta R1 by R2 cos phi 1 minus phi 2 plus I sin phi 1 minus phi 2. Same. So this is my understanding in the name of e to the power of ix. My understanding in the name of cos theta plus I sin. In both cases they are matched. So to understand the subject, we should do, or we should have the concepts of both. Same thing if I do, I want to multiply Z1, Z2. R1, R2 into cos theta 1 plus I sin theta 1 into cos theta 2 plus I sin theta 2. So if I do, so cos A, cos B, I square will become minus sin A, sin B. Cos A, cos B minus sin A, sin B is cos A plus B. I into sin A, cos B plus cos A, sin B, sin A plus B. This is nothing but cis theta 1 plus theta 2. R1, R2. So here R1 by R2, here R1, R2, theta 1 plus theta 2. This is R1, R2, E theta I to the power of theta 1 plus theta 2, E I to the power of theta 1 minus E to the power of I into theta 1 minus theta 2. So these four are correlating and matching with each other. So this is the basic definition of, if we know the expansion of sin theta, if we know the expansion of cos theta, we know the expansion of e to the power of I theta, they are matching. So this is the unit vector. E to the power of I theta is unit vector. I am multiplying with R. I am multiplying with R. See, this is unit. In this line, I am having cos theta is in the unit vector. When I multiply with modulus, I am getting the full vector. That represents my Z. That represents my x plus iy. That represents my theta. So, understood this? Now let us understand same in geometrical way. Suppose we are representing. Suppose it is a 2 plus 3a. So this point 2, 3. This vector, this arrow vector OA. OA is nothing but a complex number 2 plus 3a or simply 2, 3. Similarly, minus 1, minus 4a. This is minus 1, this is minus 4, this is minus 1, minus 4a. This is another complex number. Complex number is nothing but a vector in two plane. We know. We again see D. C is minus half, minus plus half, minus 3a. So I have given all four quadrants. First quadrant, second quadrant, third quadrant. Second is x is minus, y is plus. Fourth is x is plus, y is minus. So let us see addition of two vectors. Suppose I want to add z1 plus z2. What I will do? Z1 is a vector addition. I take this z1 onto z2. So the starting point of z1 is taken, starting point of z2, and parallel to this, the same length. I'm putting z1 plus z2. And this is my resultant. I cannot simply add z1 plus z2. I cannot add because they are having a phase difference between them. See, here 2, 3, I cannot add 2 plus 3. They are having a different phase difference. So the R is not 2 plus 3, 5. R is square root of 2 square plus 3 square less than 5. Okay. So that way the vectors are to be added with the phase difference. So this R2 is superimposed on R1, Z1. So we have this parallel to this. This is a parallelogram law. Parallelogram addition of vectors. One vector plus this another vector is tail to tail, tail to head. Then we have given a, how this angle has come. This angle is parallel to this. This is Z1 plus Z2. Suppose I want to Z1 minus Z2. So this is Z1. This is Z2. Z2, I have drawn negative cells. This is minus Z2. From tail to head is upside. From tail to head, minus side. Minus Z2. So I have put minus Z2 here and added. This become my Z1 minus Z2. Finally, what I am doing here, Z1, Z2, what is X1, X2 separately I am adding, Y1, Y2 separately I am adding. If you see here, from here to here, Z2, this is Z2, Z1 X portion. So same X portion I have added here. So Z1 of X plus Z2 of X is added. Z1 of Y, Z2 of Y is added. Here, in the minus time, Z1 of X, Z1 of X is this, Z2 of X is this. When I subtract, I am getting this X component. This is a Y component. Y is more, Y is less. So I am getting minus Y. So this is a vectorial addition in a graph. You see here, mod of Z1, Z2. Mod of Z1, Z2 is the resultant. This is the resultant. It is always less than Z1 plus Z2. As I told you, 3 plus 2 is 5. 3 square plus 2 square is less. 3 square plus 2 square is how much? 3 square is 9. 2 square is 4. 9, 13. Square root of 13 is around 3 point something. 4 square is 16. 3 point something. But 3 plus 2 is 5. So mod of Z1, Z2 is always less than mod of Z1, mod of. When they are equal, when they are in the same line. Suppose Z1 is in the same line, Z2 is same line. Suppose this is Z1 and this is Z2. So if it is the same line, they are equal. If there is a phase difference, the mod of Z1, Z2 is less than mod of Z1 plus mod of Z2. So when they are equal means they are the same angle. It need not be x-axis. Suppose OA, I write OB here. I have to add OA plus OB. So straight away get added because there is no phase difference between them. The vectors are together. So these two, the angle between these two vectors will be 0 when they are equal. If the slightest angle is there, then it is less than this. So mod of Z1 plus mod of Z2 is more than mod of Z1 plus Z2. Similarly, in this case also, it will be less than mod of Z1 minus Z2. Mod of Z1 minus Z2 is more than mod of Z1 minus Z2 individually. The reverse happens. So understand, when they are 90 degree, suppose Z1 and Z2 are 90 degree. Z1 is in this axis, Z2 is in this axis. So Z1 minus mod of Z1 minus mod of Z2 is equal to mod of Z1 Z2. Z1 minus Z2. When their angle is 90 degree. But when their angle is 0 degree, plus is equal. When their angle is 90 degree, minus is equal. Otherwise, it is less or 4. If you are able to understand this, we are able to do many of the argument problems. So Z1 plus Z2 is less than Z1 plus Z2 because this resultant is less than the individual sums. Unless they form a collinear point. Unless it comes down to this, it forms a collinear. These two are in same angle. R may be different, but argument is same. Then only it is equal. Similarly, for Z1 minus Z2, they will be equal when they are at 90 degree. That example I will show you. It's some other side. Okay. Now we'll see. What is Z1, Z2? We have just seen Z1, Z2 is R1, R2 cos theta 1 plus cos theta 2 plus I sin theta 1 plus theta 2. Their arguments will be added. Let us see here. PQ are two vectors. OP, OQ. OP is Z1. OPQ is Z2. When I multiply, so I am getting OR such that the length of OR is Z1, Z2. Their R1, R2. So Z1, Z2, their mod of Z1, Z2. And the angle is sum of these two angles. Theta 1 plus theta 2. So how this is constructed? You on x-axis you put a unit 1 centimeter. You connect these two. Now we have a triangle OAP. So my R is more than this. So this OA I am making equal to OQ. OA is becoming OQ. So then automatically this portion AP is parallel to this and OP is parallel with respect to this. I made two similar triangles. Similar triangle what? OAP and OQR. So draw OR such that its length is R1, R2 and argument is theta 1 plus theta 2. But otherwise OA is 1. So triangle OAP and OQR are similar. So you draw a OQR similar to this triangle. Because ultimately my resultant is increasing. R1, R2 is increasing. OR is larger than OPR, OQ. So I have to get a larger side here. So here, what is larger side in this table? OAP, larger side is OP. So my larger side should be similar to OP, and my smaller side should be similar to OA. So OA, OP, OAP, and OQR are similar. So OA by OP is OQ by OR. When we cross this, what are we getting? OP into OQ is OR into OA. OA is 1. We have taken this as 1. So that means R1, R2 is OR. R1, R2 is OR. So when this is theta 2, so when I have to do a similar triangle, so this is theta, because OP is at theta 1 with OA. So with OQ, I put a theta 1 with OQ. So OR is coming. So total OR is at theta 1 plus theta 2 with a modulus of R1, R2, Z1, Z2. So these are multiplied. Same is applicable in division. So this is P, this is Q. Now I am doing division. So my resultant will be less, R1 by R2. So here what happens? My OL is becoming the longer length. OQ is the shorter length. So here, what is my proportionality? OLQ and ORP are similar. OLQ and ORP are similar. Because my resultant is smaller. So I am putting out of these three, OL I am taking as OR. Here OL I have taken as OQ because my resultant is more. Here my resultant is less. So my OP is more. OP, OQ, P by Q. R is P by Q. Z1 by Z2. So R is less than P. So this is the longer side. P is longer side. R is smaller side. So OR is parallel to my OL and OP is parallel to my OQ. So finally what I mean, from OP, I draw a line which is theta 2 from OP to make it similar triangle. So draw OR such that length is R1 by R2 and argument is theta 1 minus theta 2. Here we have seen division theta 1 minus theta 2. This is graphical explanation. Draw OL with 1 unit length and triangles OLQ and ORP. So now OR is similar to OL. Here OQ is similar to OA. Instead of L I put A, same A. So here also let us say A. So OA here I made equal to OR resultant. Here OA is made equal to OQ because my resultant is more. Here my resultant is less. Understood? So this is why I got R1, R2, and when I make a similar triangle, I have to make it by theta 2 reduced. So this angle, resultant angle is theta 1 minus theta 2. So now you understood two concepts here. In this, we understood two concepts. One concept is R cos theta 1 plus I R sin theta 1 can be represented as cis theta 1, R cis theta 1. And R cis theta 1 is nothing but R into e to the power of ix. So my xy coordinate can be represented as R into e to the power of I theta. So this is a multiplication. I to the e to the power of theta, e to the power of theta 2, theta plus 1 theta 2, e to the power of theta 1 by e to the power of theta 2, e to the power of theta 1 minus theta 2. So this is my in terms of E, in terms of sin theta, cos theta, and in terms of my graphical representation. So from this also we understood mod of Z1, Z2 is less than mod of Z plus mod of Z2 unless they are collinear. Their argument is same. Similarly, mod of Z1 minus Z2 is more than mod of Z1 minus mod of Z2 unless they are 90 degree to each other. Okay, these are the concepts we learned so far from this. So based on that knowledge, now let us understand some properties of my complex numbers. So Z is A plus BI. Modulus of Z is square root of A square plus B square, which is nothing but my R. So this is XY. So R is root of X square plus Y square. And R Z is equal to X plus I. So this is my modulus and R form of complex numbers. So now let us see the formulas. Z1 plus Z2 bar is equal to Z1 bar plus Z2 bar. It is simple. If Z1 is A plus IB, Z2 is C plus ID. So what is Z1 plus Z2? Z1 plus Z2 is this one. So Z1 Z2 plus bar means minus will come here. A plus C minus I into B plus D. So what is Z1 bar? A minus IB. Z2 bar C minus ID. When I add these two, A plus C minus I into B plus D. Same. So Z1 plus Z2 bar is equal to Z1 bar plus Z2 bar. Similarly, minus also same. In place of minus, I'll put plus here. Same. In place of A plus C, it will come A minus C plus I into B minus D. Here also same. A minus C plus I into B minus D. Z1 bar minus Z2 bar. So it is all same. Now, mod of Z1 Z2. Z1 Z2 bar is equal to Z1 bar into Z2 bar. Let us understand this. Let us understand this. This is not mod. This mod is here. This is the vector itself. Z1 Z2 bar is equal to Z1 bar into Z2 bar. Let us understand this property of vector number. Here you see, this is Z1. Let us continue the properties of complex numbers. Let us understand the properties of complex numbers. We are discussing Z1 Z2 bar is equal to Z1 bar into Z2 bar. Let us understand this concept. This is Z1. What is Z1 bar? Z1 bar is this side it will come. So Z1 bar will come a mirror image of Z1. Let us say this is Z1 bar. What is Z2 bar? Again mirror image of Z2. This is Z2. This is Z2. What is Z1 Z2 bar? Z1 Z2 bar is mirror image of R Z1 Z2. Theta 1 plus theta 2. So if I see here also same O A this P dash and O Q dash R dash. So you can say Z1 bar into Z2 bar is equal to will come O R dash. O R dash is nothing but Z1 Z2 bar. So this is Z1 Z2. This is Z1 Z2 bar. If I do same type of similar triangles here also, I will get. If I do Z1 bar into Z2 bar, this is Z2 bar, this is Z2, this is Z1 bar. If I do multiplication, I'll get this equivalent. This equivalent is exactly Z1 Z2 bar. This is Z1 Z2. This is Z1 Z2 bar. Same is the case with Z1 by Z2. Same is the case with Z1 by Z2. Suppose what is Z1 bar here? This is Z1. So my this will go in this direction. Go further to length is equal to this. Again, what is Z2? My Z2 is mirror image of this. So this is further length is it? So when I divide here in this sector using same principle of parallel similar triangles, I'll get Z bar as R bar. R. So same principle is applicable. So if I do A plus BI for Z1, C plus DI for Z2, and if I do the calculations all in this partition also, I'll get the same value for these two. So what is Z bar? Z bar is A minus IB. What is Z bar modulus? Modulus is again A square plus B square. Minus B whole square is B square. A square plus. So mod of Z and mod of Z bar are equal. So double bar. So Z one bar is this one. What is double bar? Again comes to Z. See, this is Z. This is Z1 bar. What is Z1 bar? Bar. It will go back to here. Because this is Z1 bar. I have to get a mirror image. I will go back to here. So it will again Z1. So nothing but A plus IB is Z. Z bar is A minus IB. Z bar is A minus of minus IB. That means A plus IB. That is Z. So that is what is given here. Double Z. Okay. One mirror image and mirror again another mirror image. It is same. So this is regarding my vectors. Now let us see my absolute values. Mod of Z is mod of Z1. We have just seen. Mod of Z1 plus Z2 is less than Z1 plus Z2. This is also we have seen here. This is we have seen. This is Z1. This is plus Z2. In a triangle, two sides, length of two sides is more than the third side. So the third side is Z1 plus Z2. So length of two sides is more than, unless they are in the same line. Same line. Similarly, mod of Z1 minus Z2 is more than Z1 plus Z2. This is what again same principle. In a triangle, difference of two sides should be more than the other side. Difference of two sides should be more than the third side. That will come in this. Sum of two sides should be less than the other side. Less than third side. This is third side. This is third side. So mod of Z1 Z2 is mod Z1 Z2. Just we have proved. Mod of Z1 Z2. This we have not proven. This is Z bar. When Z bar is same, mod is also same. Z1 Z bar, when I have shown Z1, mod of Z1 Z2 is equal to Z1 bar into Z2 bar. That means what? Mod of Z1 Z2 is equal to mod of Z1 into mod of Z2. Let us see this one. Z1 is R1 cos theta 1 plus I sin theta 1. Z2 is R cos theta 2 plus I sin theta 2. So Z1 Z2 is equal to R cos 6 cos theta 1 plus theta 2. So mod of Z1 Z2 is what? Mod of Z1 Z2 is R1 R2 square plus cos square theta 1 square plus theta square plus sin square theta 1 square theta square. So cos square theta plus sin square theta is 1. So mod of Z1 Z2 is equal to root of R1 square R1 R2, which is equal to mod of Z1 is R1, mod of Z2 is R2. So their multiplication is R1 R2. because the modulus in the modulus cos square theta plus sin square theta will become 1. When doing modulus, cos square theta plus sin square theta is 1. Where is that one mod? Here is 1. Cos square theta plus sin square theta is 1. Same here. Mod of Z1 Z2 is equal to mod of Z1 into mod of Z2. Why? Because cos theta plus theta 1, theta plus theta 1. When a cos square theta plus theta 1 plus sin square theta plus theta 1 will be 1. So R1, R2 will be remaining. So that is same as this. That is what is given as formula here. What is given as formula. So what the formula says? Mod of Z1 Z2 is equal to mod Z1 into mod Z2. Similarly, Z1 by Z2 is mod Z1 by mod Z2. So the same principle, Z2 in terms of n is equal to mod Z into mod Z into mod Z into mod Z. So it's just like a x1 x2 is x1 into x2. X to the power of n is equal to x into x into x to the power of n. So real of Z is less than mod of Z. Imaginary of Z is less than mod of Z, because a square plus b square is Z. Root of a square plus b square is Z. So real Z is a. So root of a square plus b square is more than a. Root of a square plus b square is more than b. So root of b, root of a. So that means mod Z is more than individual parts. Individual parts. So let us see this one. So these properties we have to understand mentally so that we can address any problem. Mod of Z1 plus Z2 is less than Z1 plus individual Z2 we have given, but is giving what they are equal to. See, what they are equal to. Here it is given mod of Z1 plus 2 is less than Z1 plus Z2. But what we put squares. What is becoming square? Let us see here. Z1, Z2. Z1, let us say A plus ID. Z2, C plus ID. So Z1 plus Z2 is this one. So I am putting mod of this. What is mod of this? Z1 plus Z2 whole mod of this square is equal to Z1 square plus Z2 square plus 2 into AC plus BD. You see here, this is A square plus C square plus 2AC. So A square is there, mod of Z1 square. C square is there, mod of Z2 square. So A square plus C square I converted as mod of Z1 square. Again B square plus D square. This is B square plus D square. So B square plus D square. So what is mod of Z1, Z2? A square plus B square. So I is only a vector product, but when you do modulus, it is the A square plus B square is the modulus. So A plus C whole square plus B plus D whole square. So A plus C whole square is A square plus C square plus 2AC. B plus D whole square is B square plus D square plus 2BD. So what is left over here is 2 into AC plus BD. 2 into AC plus BD. So now 2 into AC plus BD, we have to prove that they are 2 into real part of Z1, Z2 bar. So I am putting Z1, Z2 bar is C minus ID. Z1, Z2 bar is C minus ID. If I multiply this Z1 into Z2 bar, what I am getting? AC plus BD. I square is minus I square. No, AC plus BD is the real part. AC plus BD is the real part. So this is what is given to real part of Z1, Z2 bar. See, I am multiplying Z1, Z2 bar. What I am getting here? A plus IB into C minus ID. A plus IB into C minus ID. So this is nothing but AC plus BD minus I into we are getting. But so 2 into AC plus BD is my real part. From this I got 2 into AC plus BD. So 2 into AC plus BD is the real part of Z1, Z2 bar. Here I've added some other also to prove something else, but I am limiting to this here now. Z1, Z2 bar, real part of this is AC plus BD. You see here, Z1 into Z2. Z2 bar is C minus ID. C minus ID. So AC minus I square BD. I square means minus I square plus. So AC plus BD. AC plus BD is the real part of Z1, Z2 bar. So 2 into real part of Z1, Z2. This is mod of Z1 plus 2 whole square. So when they are in the real part. Now again mod of Z1 minus Z2 whole square. They are minus of 2 into real part of Z1, Z2 bar. So here it becomes minus 2 into AC plus BD because Z1 minus Z2. So the minus will come here. So minus of 2 into AC plus BD, nothing but 2 into AC. AC plus BD is the real part of Z1, Z2 dash. So 2 into AC plus BD is 2 times real part of Z1, Z2 dash. So minus. So if we do X plus IY and X minus IY, we get this clearly. So this we have seen mod of Z1, Z2 is less than mod of Z1 plus Z2. Mod of Z1 minus Z2 is more than mod of Z2. To prove this, in earlier we have seen in geometric manner. This is a triangle, two sides are less than the third side. This is what we have seen. But we'll see in a physical form. Let us see. Now we are going to prove this one. We are going to prove this one. Mod of Z1 plus 2 should be less than mod of Z1 plus mod of Z2, unless they are in the same line, unless they are in the 90 degree. Same line, and they are 90 degree to each other. But let us see this. Z1 plus Z2 is X1 plus X2 whole square plus Y1 plus Y2 whole square. Mod of Z1, root of X1 plus X square, Y2 whole square. Mod of Z2, root of X2 square plus Y2 square. This is Z1 is X plus I, X1 plus IY1, Z2 is X2 plus IY2. So this is the basic, the three are coming here. This is Z1 square, Z mod of Z1, this is mod of Z2, this is mod of Z1 plus Z2. Now I have to prove that this is less than these two. The one side of triangle is less than sum of the two sides. Z1 is the length of the, this is the resultant. So let us prove this. So we have to prove that this is less than this. I am doing squaring both sides. So here root will go. Here a square plus b square, 2ab will be coming. 2ab will be coming. So when these squares get cancelled, 2x1 x2 plus 2y y2 is left out here. So again I am squaring. Again I am squaring. Here also, then what happens? 4 x1 square, x2 square, 4 y1 square, y2 square, they get cancelled. So what is left out here? This is 2ab, 4 x1, x2, y1, y2. 2 is cancelled before itself, so I am keeping 2ab here. So here also, what is left over? X1 square, y2 square plus x2 square, y1 square is left over. So if a square plus b square minus 4ab is, again I am squaring both sides. Again I am squaring both sides. Again, what I am getting here? A square plus b square minus 4ab. This is a square, b square. I am putting whole square. Again, I am squaring. So this becomes a square, a plus b whole square. This becomes a plus b whole square. This being 4 x1 square, x2 square, y1 square, y2 square. I bring it here. So a plus b whole square minus 4ab becoming a minus b whole square. So this is a minus b whole square. It is almost plus, because whole square is always plus. So this is less than this. So we have proven that 2x1 x2 x2 is less than this. We have proven this is less than this. And finally, z1 plus z2 is less than z1 mod of z1 plus mod of z2. Similarly, this can be proven higher also. So let us see, when I am adding these two, mod of z1 minus z2 square plus mod of z1 plus z2 square. What I am doing here, these two, z1 plus z2 square plus z1 minus z2 square. I am adding these two. So these two get cancelled. These two terms get cancelled. So I am getting 2 into mod of z1 square plus z2 square. This is a derivation from these two. This we have already seen here. What's the last one? Mod of z1 plus z2 whole square. If it is equal to mod of z1 square plus z2 square, that means we have seen it is purely imaginary. Z1 by Z2 is imaginary. That means they are 90 degree. See, when this will happen, Z1 plus mod of Z1 plus Z2 whole square is mod of Z2 square plus mod of Z2 square. Let us understand this. Let us assume this is Z1 and this is Z2. This is Z2, this is Z1. So what is mod of Z1? Mod of Z1 is X. What is mod of Z2? Mod of Z2 is Y. So what is mod of Z1 square plus Z2 square? X square plus Y square. X square plus Y square. What is mod of Z1 plus Z2? Mod of Z2 is root of X square plus Y square. So they are equal. That means Z1 by Z2. Z1 by Z2 means these two are 90 degree. There, Z1 by Z2 is purely imaginary line. That means it's a 90 degree line. Z1 by Z2 means what? You have seen here, Z1 by Z2 is cis theta 1 minus theta 2. Theta 1 minus theta 2 is what? 90 degree. So cis 90 is cos 90 plus I sin 90. Cos 90 is 0. We have only I sin 90 is 1. So R1 by R2 Y. That means it is only having an imaginary component and no X component. This becomes 90. Theta 1 minus theta 2 is 90. This is here. Z1 by Z2 is nothing but theta 1. What is theta here? This is 90. What is Z1 theta? 0. So 90 minus 0, 90. This idea, suppose you take another, let us say this Z2 and this are 90 degree. So resultant is automatically my A square plus B square. Here it is 90. If it is 90, then it is resultant is A square plus B square. So mod of Z1 square plus mod of Z2 square is equal to mod of Z resultant square. This is resultant is nothing but Z1 plus Z2. This resultant is Z1 plus Z2. If this 0, suppose if it comes 0, then Z1 square plus Z2 square plus 2Z1 Z2. Mod of Z1 plus Z2 is nothing but what? Z1 square plus Z2 square plus 2Z1 Z2. It is more than mod of Z1 plus Z2. But they are 90 degree, then we have this A square plus B square is C square. So when they are equal means what? They are 90 degree. If we don't have any 2 Z1 Z2, we don't have any 2 Z1 Z2, that means they are 90 degree. They are purely imaginary. Cos 90 is 0, sin 90 is 1. So ours is theta 1 minus theta 2, 90. So R1 by R2. The value is R1 by R2 in the Y axis. The Y axis. There is no X axis here. Purely imaginary. Here, real part is 0. When they are 90 degree, what is my real part? It will be 0. Z2 bar. Real part Z1, Z2 bar. There 90 get cancelled, become 0. 90 it will become. So it is real part is 0. Cos 90 is 0. Let us go back. So these are the formulas which we will be doing some exercise on these formulas. Once we graphically should understand what is Z1 into Z2, what is mod Z1 Z2, what is mod of Z1 into mod of Z2. We should be able to graphically understand. We should be able to this exercise. We should understand the basic concepts A plus IB, C plus ID, and we should also be able to understand the concepts so that we can do problems on this issue. So let us see some small problems. Suppose this is there. So I am doing conjugate of this. So I am getting minus I. What of mod of Z? Mod of minus I is 1. What is tan theta? 45. Tan theta is y by x. X is 0. Tan theta is tan inverse 1 by 0. That is minus pi by 2. Minus pi by 2. Because it is y is minus 1. It is coming to bottom side. So minus pi by 2. So Z is equal to mod Z cos theta plus I sin theta. That is cos pi by 2 minus I sin pi by 2. Because it is minus I. So your real part is 0. Real part is 0. You have only imaginary part. These two are what? These are conjugate. 1 plus I and 1 minus I is conjugate. These two are conjugate. So Z1 minus Z2, this gets 0. So this is having theta 1, this is having minus theta 1. So this is theta 1, this is minus theta 1. When minus, this is minus plus theta 1, this is minus theta 1. So minus theta 1 minus of plus theta 1. So minus 2 into theta 1. So minus 2 into theta 1 with this figure is becoming minus 90. Minus 90. So let us understand, we have to simplify this. There are 3 multiplications. So first let us simplify 2 into this. 2 3s are 6i. This is 2i. 2i into I square minus 2 is plus 2. Again multiply this and the other one. I'm getting what is this? 8 into 4 plus 3i. So what is here? R square. So we have 32 square plus 24 square. 8 3s are 24. 8 4s are 32. Square root of 32 square plus 24 square is R is 40. So what is the angle here? 40 is 32 by 40 cos theta, 4 by 5 sin theta, 24 by 3 by 5. So A is tan inverse 3 by 4. Y by x, y is 24 by 32. So this is 4, 6 4s, 4, 8 3s and 8 4s. Tan inverse 3 by 4 is my argument. So we have simply found out a multiple for this number, complex number we have converted to single number, and we have found out its radius, angular modulus, and its argument. Similarly here, we have given 2 minus 2i. So Z is 2 minus 2. What is R cos? R is R. R is equal to root of 2 square plus 2 square 2 root 2. R is 2 root 2. So R cos theta is 2. R sin theta is minus 2. So tan theta is minus 1. What is minus 1? Minus 45. So this is the, finally it becomes R cos theta plus R sin theta. Here theta is in tan theta minus means what? It is in second quadrant or in fourth quadrant. Because third quadrant is positive, first quadrant is positive. So this is second and fourth quadrant. So I write pi minus 45 or minus 45. Both are possible. Now let us practice some problems on complex numbers. Let us see. If Z is not 0, if Z means vector. This is z vector. Find arc z plus arc z dash. If this is z, then this will be z dash. So mirror image, this is minus z. Opposite is minus z, but is asking z dash. So this will be z dash. So what is, we have to find arc z plus arc z dash. If this is theta, this is another theta. So it will be almost minus 2 theta. Let us see. Z is x plus I by z dash is x minus I by. Z plus z dash is 2x. Z plus z dash is 2x. So minus theta plus theta, they get cancelled and become 0. This arc is x-axis, it is on x-axis. So y is 0. What is that? Resultant is on x-axis. This is one vector. This is one vector. They are symmetrical with x-axis. So their y component getting cancelled. There is only x component is left out. So the arc is, with respect to x-axis, what is its angle? The resultant is 0. So the arc is 0. Suppose if this is z, this is z. You have a z dash here. So here the resultant arc is minus pi. This is minus pi. It is z dash. The resultant is in along minus x direction. Though it is pi. Resultant is either pi or minus pi. So if arc z is pi, arc z is pi, then z dash is also pi. The result is also pi. So minus. So these two possibilities are there. So let us say, find arc minus z. If arc z is less than 0, find arc minus z. So let us say this arc z, it is less than 0. This is 0. This side is positive. This side is negative. So let us say it is minus theta. So minus z is quite opposite to this, same length. So this is a straight line, is a pi. So what is the arc of this? Pi minus theta. So arc of minus z is pi minus theta. Suppose if it is plus theta, then this will be minus z. So this total is minus pi. So this total is pi. So from here, this portion is pi minus pi plus theta. So like that, we have to see which quadrant z is there. Of course, this is also minus theta. So z is here, minus theta on this side. So plus z will be here. So from here to here, this is 180. So from here onwards, this is, we have to reduce this theta from pi. So this is pi minus theta, same as this. So this is a relation between z and minus z. If z1 is minus 1, z2 is minus n. Z1 is minus 1 means there is an arrow here up to 1. Z2 minus m is here in this particular here. Find the arc of z1, z2. This is z1, this is z2. Arc of z1, z2 is theta 1 plus theta 2. This is pi, this is pi by 2. So total minus pi by 2 is the resultant. So arc of z1, z2 is arc of z1 plus arc of z2. Minus 1 is, z1 is minus 1, I portion is 0. 0 by anything is 0. So this is taken as 0. Arc of z2 is minus pi by 2. So this is minus pi by 2. So we are coming from here to plus 3 pi by 2 or minus pi by 2. So if z1 is minus 1, z2 is I, find arc of z1 by z2. Here z1 into z2, here z1 by z2. So this minus this. So arc z1 minus arc z2 is equal to 0 minus of minus pi by 2. That is pi by 2. Yes, this is z1 is pi. From this pi, we have to remove this z2 portion. So this is pi by 2. Pi minus pi by 2 is plus pi by 2. See, this is what is this? Minus 1 plus 0 I. This is nothing but minus 1 plus 0 I. Mod z1 is 1. but Z1 vector is -1 means this is Z1. This is angle of 0 is wrong. It is angle its argument is pi, and this argument is -pi/2. -pi/2. So in the same direction, if you see pi minus pi/2 is pi/2. So this is Z1 plus Z2. This is Z1 by Z2. And let us see this. Cos 2a plus I sin 2a and cos 2b plus I sin 2b. This is equal to 6 theta 1 into 6 theta 2 is equal to 6 theta 1 plus theta 2. 2a plus 2b, which is nothing but c. So c is equal to 2a plus 2b. And if you multiply what we are getting, cos a cos b minus sin a sin b. So z cos a plus b. All these things will get. So if z is this, I have to convert into polar form. What is the mod of z? 3 plus 1, 4 under root 2 is the mod of z. What is the angle? 1 by root 3. 1 by root 3 is pi by 6. So 2 cos pi by 3, pi by 6 plus I 2 sin pi by 6 is the first quadrant. So if z2 by z1 is an imaginary number, find the value of mod of this. We have to find out mod of this. So here z2 by z1 is an imaginary number. Z1 is not 0, and this z2 by z1 is imaginary. Like this pi by 2. Here of course z1 by z2. So here I am taking z2 by z1. Here I have taken z1 out. So 2 plus z2 by z1. Here also taken z1 out. 2 minus z2 by z1. These two get cancelled. So 2 plus z2 by z1. 2 minus z2 by z1. Let z2 by z1 be represented by pi. Because it's only imaginary. Z2 by z1 is only imaginary. Some value of 5. So 2 plus iy by 2 minus iy. By conjugate division, I get 4 minus y square plus 4iy by 4 plus y square. So what is the mod of this? A square plus b square under root this. So root of 4 minus y whole square plus 4y whole square by 4 plus y square. So when I simplify it, I am getting 1. I am getting 1. So that means what? Z2 by Z1. This 2Z1 plus Z2 by 2Z1 minus, it is like a conjugate. 2Z1 plus Z2 and 2Z1 minus, they are conjugate to each other. Conjugate to each other. So the value is 1. Mod of the conjugate is 1. Root 3 plus I whole to the power of 100 is given as 2 to the power of 99 into a plus ib. Find ab. So how to proceed? Let us convert this into my polar form. Root 3 plus I, we know polar form, we have just seen 2 cos pi by 6 plus I sin pi by 6. You have seen here. So what is the modulus of this? 3 plus 1, 4 under root 4 is 2. So what is angle? Tan of 1 by root 3. Tan A is pi by 6. So 2 to the power of 100. So 2 to the power of 100 into cos 100 into pi by 6 plus I sin 100 into pi by 6. You have just seen this. Theta 1 plus theta 2 or cos 100 into pi by 6 plus I sin 100 into pi by 6. So when I simplify, equate, 2 to the power of 99 get cancelled. So 2 goes inside. So the value is 2 cos 2 pi by 3 plus I sin 2 pi by 3. So A is equal to 2 cos 2 pi by 3. B is equal to 2 sin 2 pi by 3. This is A. So if I apply 2 pi by 3 value, A is coming -1, B is root 3. So answer is A square plus B square. Is equal to 1 plus 3, that is 4. So the modulus of this is also 4. Now let us say, if Z is x plus iy, mod Z is 1, we have to find locus. So what is the mod of z? X square plus y square is equal to 1. This is a circle of with radius 1 at the origin as center. So such problems will come. We have to find modulus and locus. So this is, if z minus 1 is pi by 2, find locus. Z minus 1 is what? X plus I by, let z be x plus I by. So x minus 1 plus I by. What is this modulus? Tan theta is equal to y by x minus 1, which is equal to pi by 2, tan pi by 2. Tan pi by 2 is infinity. Sin pi by 2 by cos pi by 2, cos pi by 2 is 0. So that means x minus 1 is 0. That means x is equal to 1. X is equal to 1 and y is not 0, y is more than 0. So this is the locus of this condition. Suppose z is given, find the argument of z. When I simplify this, 1 plus 2i, I am also getting this as 1 plus 2i. Because 1 minus I whole square, 1 plus I square 1 get cancelled. Then I get here minus 2i, minus into minus plus 1 plus 2i, those get cancelled. So 1 means along x-axis. So argument is 0. Y is 0. So tan theta is 0 by 1 is 0. 0 is, that means theta is 0. So here find the modulus. Let us simplify this. 2 plus I into 1 plus 2i. So when I multiply 2 1s are 2, 2 1s are 2, I into I, 2i square. 2i square is minus 2. Then it is 0. So 1i plus 2i, 4i is 5i. So when I further simplify it, is whole cube. 1 plus I whole cube. A cubed plus 3 a square b plus 3ab square plus b cubed by 5i. When I am simplifying it, I am getting this form. So modulus is 2 square by 5 plus 2 square by 5. So 2 root 2 by 5. This is the modulus under root. So 2 root 2 by 5 is the, so what we have done here, we have simplified to the lowest form. And we have a plus ba form. We will form of it modulus. Similarly, modulus of this 4, we have to find locus. So this is z minus, let z be x plus iy. So x minus 3 plus y into y plus 1 into I. X minus 3 plus I into y plus 1. So what is modulus of this? Is a square plus b square is equal to 4 square. Square plus b square, under root is the modulus. Now we have removed under root, so I got 4 square. This is a circle with the center as 3, 1, 3 and minus 1 is the center and its radius is 4. This is the locus of this condition of complex number. Let us see this problem. 1 minus I into 2 minus I up to n minus I is equal to x minus iy. Then prove that this is the condition. X square. So you know x minus iy, what is the mod of this? Mod of this is x square plus y square. So now I have to find out mod of this. So mod of this is equal to mod of this into mod of this into mod of this, individual mods. 1 minus I into 1 minus 2 1 minus 3 up to this is equal to, I take both mod of this. So mod of this, mod of this, mod of this is equal to mod of this. So I have taken out root. So then what is happening? So what is the mod of this? 1 plus 1. This is 1 plus 4. This is 1 plus 9. 1 plus 4 square. 1 plus, because a square plus b square. Mod is b square. So a square plus b square. So this is nothing but this is the 2 into 5 into 10 into 10 to the power of 2n plus 1. N square plus 1. If n is 1, I am getting 2. If n is 2, 2 square plus 1, 3 square plus 1, 4 square plus 1, 5 square plus 1, like that n square plus 1 is equal to x square plus y square. Here what is that we have used? Use the formula mod of z1 z2 is equal to mod of z1 into mod of z2. This is the formula we have used. So individual mods we have multiplied. So suppose if mod of z plus 4a plus mod of z minus 4a is equal to 10. Find relation. What is this representing? Locus. So let z be x plus iy. So x plus I into y plus 4 plus x I into y minus 4. What is the mod of this? Square root of x square plus y plus 4 whole square. What is mod of this? Square root of x square y minus 5 whole square is equal to 10. So I am squaring both sides. I have taken this and squaring both sides. I have simplified it. So I got 16y minus 100 is equal to minus 20 root. Again I am squaring. Again I am squaring. I got this. Here I have removed a common. I have removed 4. 4 5s are 20. 4 25s. 4 4s are 60. So here I am again squaring. So that this root goes out. So when I simplify, I am getting x square by 3 square plus y square by y square is equal to 1. This is what it is representing, a ellipse. X square by a square plus y square by b square is 1. This is an ellipse with a major axis as 5 in the y along and minor axis 2y. This is y square by b square. 2b is major axis and 2a is minor axis. This is smaller here. So this is parallel to vertical. This is a locus of ellipse with center 0 0 with major axis vertical. Okay, so let us see next one. So these are the problem. If mod of Z1 plus Z2 is equal to individual mods, then prove that the argument of Z1 minus Z2 is 0. See, there are two methods. One is the graphical method. Mod of Z1 plus Z2 is nothing but OR, is a resultant of Z1 and Z2. If mod of this Z1 is equal to these two, mod of Z1 plus mod of Z2, that means they are in the same line. Otherwise, in a triangle, sum of two sides is more than third side. If they are in the same line, that means arc of Z1 is equal to arc of Z2. Their minus is 0. So theta minus theta is, they should be in the same arc. This is a graphical. Let us see my Cartesian coordinates. If Z1 I am taking x1 plus iy1. If Z2 I am taking x2 plus iy2. So mod of Z1 plus Z2 is x1 plus x2 plus I into y1 plus y2. So this is the mod of Z1 plus Z2. This is the mod of Z1. This is mod of Z2. This we have already done earlier to prove that it is less than that. Now it is given they are equal. So let us see. So when squaring both sides and simplifying, I am getting x1 x2 plus y1 y2 is this. Again I am squaring. So what I am finally getting? I am finally getting x1 y2 is equal to y1 x2. That means y1 by x1 is equal to y2 by x2. That is also arc of Z1 is equal to arc of Z2. Y1 by x1 is arc of Z2. So they are under same slope. Then only they will be equal. Otherwise, it is less than this. The resultant is less than the two sides we have seen in Cartesian coordinates. A triangle. Let us see in a different. The same question can be in a different way. If arc of Z1 is arc of Z2, so the arc of both are the same angle. Prove that mod of Z1 minus Z2 is equal to mod of Z1 minus mod of Z2. Here plus, here minus. So let us see. I am seeing in the polar coordinates. Let me prove this in polar coordinates. This we have already done. We understood how to do this. Let us do this way. Let Z1 be mod of Z1 cos theta 1 plus I sin theta 1. Z2 be mod of Z2 cos theta 2 plus I sin theta 2. So when I have mod of Z1 minus Z2, first I am calculating. It is given that arc of Z1 is arc of Z2. That means theta 1 is equal to theta 2. So now I am putting mod of Z1 minus Z2. So what is Z1 minus Z2? Z1 cos theta 1 minus Z2 cos theta 1 plus I into Z1 sin theta 1 minus Z2 sin theta 1. Because theta 2 is theta 1. Now I am finding mod of this. So a square plus b square. This is a square, this is b square. So when I simplify it, I am getting root of Z1 square plus mod of Z2 square minus 2 mod Z1 Z2. This is a Z1 minus Z2 whole square. Mod of Z1 minus mod of Z2 whole square. So these two get cancelled. So what I am getting? Z1 minus Z2 is equal to mod of Z1 minus mod of Z2 if their arguments are on same line. Here also argument is same line. Here also argument is same line. You see here, same concept we can understand simple technique by graphical method. Let OA is Z2, Z1. Let OB is Z1. Because their argument is same. They are in the same theta. So what is Z2 minus Z1? AB. Z2 minus Z1 is AB. Mod of Z2 minus Z1. So mod of A minus mod of B. Mod of Z2 minus mod of Z1. So mod of Z1, A is Z1. So mod of Z1 minus Z2 is equal to Z1 minus Z2. Because AB is equal to OA minus OB. OA minus OB. So this is a simple understanding when they are equal. Okay. Let us see this problem. If mod of Z1 plus Z2 plus Z3, what is its value? If Z1, Z2, Z3 are complex numbers such that the mod is equal to 1. Mod is equal to 1 means argument can be anything. In a unit circle, it can be anything. And also given condition that 1 by Z1 plus 1 by Z2 plus 1 by Z3 is also 1. So what is Z into Z bar? That Z is X plus Iy. Z bar is X minus Iy. So Z into Z bar is X square minus I square Y square. X square minus I square Y square. So when I is getting cancelled, I square becomes minus 1. So this becomes X square plus Y square. Z into Z bar will become X square plus I square is mod Z. Equal to mod of Z. So this is mod Z whole square. Because mod Z is root of X square plus Y square. So, but Z into Z bar is nothing but X square plus Y square. Root is not there. So this is Z square. But here mod Z1 is given as 1, Z2 is given as 1, Z3 is given as 1. So Z square, Z1 square, Z1 are same. So let us see here. We have 1 by Z1 plus 1 by Z2 plus 1 by Z3 is 1. Using this combination, in place of 1, I am putting mod of Z1 square. Here mod of Z2 square, here mod of Z2, Z3 square. So this with this formula becomes Z1 bar plus Z2 bar plus Z3 bar. This is the beginning. Z1 bar plus Z2 bar is equal to 1. So when the mod is equal to 1, so we know mod of Z1 bar is mod of common bar. So Z1 plus Z2 plus Z3 common bar is equal to 1. So this is only a real number. There is no imaginary here. 1 plus I 0. 1 plus I 0. So X bar is equal to X. When everything is real, X bar is equal to X. So Z1 plus Z2 plus Z3 without bar is also 1. Because Y is 0. Y is 0. So X plus Iy, X minus Iy, Iy component 0. So this is also 1. So this answer is 1. So how we have proceeded? We are using this. This is dot Z squared by Z is equal to Z. So from that, we Z into Z bar are vectors. When I multiply two vectors, what I am getting? I am getting Z is modulo square. So that formula is used. Now let us see here. Prove that arc of Z1, Z2 is equal to Z1 is equal to Z minus dash dash. Arc of Z1 by Z dash, Z bar. Z1 by Z bar. Z1 into, this is into, then this will be Z dash. See, arc of Z dash is equal to arc of Z minus arc of Z dash. Let us say Z1, Z2. In fact, these are all Z1s, they are not same. Z1, Z2. Let Z1, Z2 bar. Z1 is R1 cos theta 1 plus I sin theta 1. Z2 is R2 cos theta 2 plus I sin theta 2. R2 cos theta 2 minus I sin. Z2 bar I am giving, bar is minus I sin theta 2. This is only R1 cos theta 1 plus I sin theta 1. So what is Z1, Z2 bar? I am multiplying. This is theta 1, this is theta 2. This is wrongly given here. This is cos theta 1 plus I sin theta 1 into R1. So when I am multiplying R1 to R2, R2, cos theta 1, cos theta 2, I into I square plus sin theta 1 sin theta 2 minus I into cos theta 2 sin theta 2 sin theta 1 cos theta 2. So this is becoming a cos theta 1 minus theta 2 plus I sin theta 1 minus theta 2. This is nothing but the argument of this Z1 Z2 bar is equal to theta 1 minus theta 2, nothing but arc Z1 minus arc Z2 bar. Z2 bar. Here is slightly confusing. This is theta 1, theta 1. We have to, this is only R1, R2 is not there. Okay. Now let us see this one. If mod of is equal to 1, what is, and Z1 plus Z2 is 0. Here mod is equal to 1, 1 by Z1 plus 1 by Z2 is 1. Here this condition is 0. Then what is the area of this vector points? Area of the triangle whose vertices are Z1, Z2, Z3. Now what I want Z1 minus Z2. This side I will get. I want Z2 minus Z3. This side I will get. I want Z3 minus Z1. Third side. Three sides are. When I find three sides, I can find the triangle. Area of a triangle. So now I am finding. Let us see this one. What is this a plus b whole square? A square plus b square plus 2ab. A square plus b square minus 2ab. 2ab getting cancelled. So 2 into a square plus b square. So we have given Z1 plus Z2 is equal to minus Z3. So minus Z3 or Z1 minus Z2 I am keeping as it is whole square. So 2 into Z1 square plus Z2 square. Mod of Z1 square plus mod of Z2 square. Mod of Z1 is 1. Mod of Z2 is 1. So 2 into 2, 4. So Z3 is also 1. 4 minus 1, it becoming 3. So Z1 minus Z2 is root 3. So that means distance between Z1 and Z2 points is root 3. Similarly, Z2 minus Z3 is root 3. Z3 minus Z1 is root 3. This is a equilateral triangle of side root 3. So half base into side, I am getting 3 root 3 by 4. So how we have proceeded here? I have used this formula. A plus b whole square plus a minus b whole square is 2 into a square plus b square. Here it is mod Z1. A is mod Z1, B is mod Z2. Mod Z1 plus Z2 whole square plus mod Z1 minus mod Z2 whole square. Okay. Now let us go. Let us continue complex numbers. Because complex number is being in the plane, all geometrical figures will come under complex numbers. Whether the locus of a circle, of a hyperbola, of an ellipse, all comes under our quadratic. All these equations coming under our complex numbers. Let us see. These are all the this is Z and minus Z. If 2 plus I is Z, minus 2 minus I is minus Z. Similarly, 1 minus 2I is Z, minus 1 plus 2I is minus Z. So this is the complex numbers of minus Z. Of course, we have already seen the conjugate of this mirror image, x plus iy, x minus iy. Y component is minus. If you see the perpendicular bisector, so all the points on this line, center line between I and I dash, form a perpendicular bisector to the points I and I dash. So Z minus I of mod is equal to Z minus I dash. So this is my mod equation. When I put this equation, I'll get the locus of points which are equidistant from this. Similarly, if I want a point which is within this forming the line, then means whatever the argand is same, the slope is same. Z minus Z1 by Z minus Z2 is 0. Then only all the 3 points lie in the same. Suppose Z is here. Z minus Z1 is having some slope, Again, z minus z2 is having one slope. So the slope should be same. That means they are collinear. They are the same line. So these are the locus of points which form collinear points with these 2 points. Suppose you want a circle. We have just seen z minus z0 center is equal to mod of this is root of a square plus b square. So root of a square plus b square is r. So x square plus y square is r square is for a locus of circle. So all complex numbers can be converted to this locus. Now you see the ellipse. What is the diametric form of circle? Diametric form of circle says z minus z1 mod of z minus z1 by z minus z2. The arc between them is 90 degree. This is 90 degree because both diametric endpoints make 90 degree. So z minus z1 by z minus z2 is 90 degree. The arc of it. So this is nothing but theta 1 minus theta 2. Theta 1 minus theta 2 is 90 degree. For ellipse, we know ellipse r1 plus r2 is equal to 2a. r1 plus r2 is equal to 2a major axis. So z minus z1 mod of z minus z1 plus mod of z minus z2 is equal to a fixed distance 2a. So when we got the focus points, I can find out this locus with respect to z of x and y. So r1 plus r2 is 2. For an hyperbola, suppose this is z point. Z minus z1 minus z minus z2 is equal to 2x. Here it is plus is 2a, here it is minus is 2a. Because suppose from this point, let us say this is hyperbola point, let us say point A0. A0 from this, from focus, what is the distance here? This is c minus a. This is 0, 0, this is c, this is a. So this point is c minus a. And this point is, this is c plus a, c plus a. So c minus a plus c plus a. This is 2a. Like that, d2 minus d1 is always 2a. This is hyperbola. So we will get points. We will define hyperbola points with respect to these two. So we can find out z, x, y with these two, the locus. Let's see this problem from exercise. These problems are from exercise. Find the equation of perpendicular bisector. If you see here, this is a conjugate. So 1 plus 7, 7 minus 7. So that means what x-axis is the perpendicular distance between these two. So answer is y is 0 and z is x is 0. So equation of line joining these 2 points. We know what is the equation of line joining 2 points? Y minus y1 is equal to m into x minus x1. So y minus 6 is equal to m into x minus 11. What is m? y1 minus y2 by x1 minus x2. 6 plus 4 by minus 9 minus 11. So this is the equation of the line joining these 2 complex points. Now, if 2 into z minus 2 is equal to z minus 1, what is the locus? This is mod of z minus 2. Let z is x plus I by. So this will be x minus 2 whole square plus y square is the mod of z minus 2. This is x minus 1 whole square plus y square is the mod of z minus 1. So when I put 2 square also, because mod is square root of that. Square root of this is 2 into square root of this is equal to square root of this. I have removed square root, so I put 2 square also here. So when I simplify this, I am getting a circle equation. X square plus y square minus 14 by 3x plus 5 is equal to 0. Is the center of 14 by 3, 7, 2gf, 2gx. So 7 by 3 is the center and 0 is the center. 7 by 3, 0 is the center and radius is g square plus f square minus c. R square is g square plus f square minus c. So that is around 0.667. So let us see the another. If image of z square is 4, find the locus of the points. So z is x plus I y. So I am putting whole square, x square minus y square plus 2y xy. So what is image of this is? Imaginary point of this is 2x. So 2xy is equal to 4. Xy is equal to 2. This is the locus of this given condition. Let us see if arc of z minus 1 by z plus 1 is equal to pi by 4. Find out the locus of this. So that means what? The angle between z minus 1 and z plus 1 vectors is pi by 4. Let us see pi by 4. So x minus 1 plus iy minus x plus 1 minus iy. So what is the arc of this? Tan inverse y by x minus 1. This is arc of this, tan inverse y by x plus 1. These two, the difference is equal to pi by 4. Now, what is the simplification of this? Let tan inverse y by x1. Let us say, I am drawing a tan inverse tan inverse x is equal to a. Let us say tan inverse y is equal to b. So then tan comes this way, tan a is equal to x, tan b is equal to y. So what is tan of a minus b? We know tan a minus tan b by 1 plus tan a tan b. So a minus b is equal to tan inverse tan a minus tan b by 1 plus tan a tan b. What is tan a? Tan a is x, tan b is y. So x plus y by 1 minus xy. Thus this formula we're using here. So this becomes tan inverse x plus y by 1 plus, this is y a minus b. So x minus y by 1 plus xy. X minus y by 1 plus x and y. This is when I'm combining two tan inverses with a minus in between. So this is the way. This is an example I have shown how they combine. So once we simplify this, the central portion, what I am getting? This tan goes this side, tan pi by 4. Tan pi by 4 is 1. So this inside equation is 2y by x square. X square plus y square minus 2y minus 1 is 0. This is nothing but a circle. Circle with 2gx is 0. So x point is 0, y point is 1, which represents a circle. So arc of z minus 1 by z plus 1 is equal to pi by 4 is representing me a circle. Mostly these such problems are represent circles. Here also you see z minus representing a circle. So whenever such type of z plus 1, z minus 1 given, mostly they are representing a circle. Let us see next. See the next problem. Show that the complex numbers form equalator. There are three numbers are given, 3 points. So we have to see the z1, z2, what is the distance, z2, z3 and z3, z1. So between z1 and z2, x1 minus x2, 2 minus 2, 2 minus of minus 2 is 4, 2 minus of minus 2 is 4. So what is the modulus of this? 4 square plus 4 square, that is root 32. Now z1 to z3, 2 plus 2 root 3 whole square, 2 minus 2 root 3 whole square. This is a plus b whole square plus a minus b whole square. So 2 into a square plus b square, that is root 32. Similarly, z2, z3 also we can say root 32. So all the distances are same. So these 3 points form equilateral triangle. Let us find what is the eccentricity of this ellipse. This is in the form of mod of z minus s1 plus mod of z minus s2 is equal to 10. That means what? The r1 plus r2 is equal to 10. That means 2a is equal to 10. This is in the form of circle distance z minus z1 we have seen here. Here it is z minus z1 plus z minus z2 is equal to 2a. This is that point, general point. Z minus z1 plus z minus z2 is equal to 2a. So same format is given. So here nothing but z1 is equal to 4 0, z2 is 12 by 5 0, s1 s2. So 2a is 10, a is equal to 5. Now we got s1 we got 12 by 5 0 and s2 we got 4 0. Both are on the same side of x-axis, but this is ellipse is centered at this point. So what is the distance between s1 and s2? This is the distance between these 2 points. So 4 minus 12 by 5, that is the distance. This x-axis only y 0 0. So 8 by 5. So s1 s2 is nothing but 2ae. This is ae, this is ae. This is a by e. So total ae. So this is ae plus ae, 2ae. S1 s2 is 2ae. So we can find out eccentricity is 4 by 25. So we should have the knowledge of ellipse and you should know how to identify these 3 numbers given. Okay. Now suppose if z3 minus Z1 by Z2 minus real. Real means there is no imaginary component. That means Y is 0. Y component is 0. So that means what? They are same slope. Z3 minus Z1 and Z2 minus Z1 are same slope. That is that itself shows that they are like this. Z3 minus Z1 is having some argand. Z2 minus Z2 is having same argand. So that means they are in the same line. Otherwise, if you want to see in X and Y cases, same thing. Z1, if I say X1 plus IY1, Z2, Z3. Let us say Z3 minus Z1 by Z2 minus Z1. This is Z3 minus Z1 by Z2 minus Z1. So for this to be real, all I components will become 0. So in the numerator, I component is Y3 minus Y1 is equal to 0. In the denominator, I component is Y2 minus Y1 is equal to 0. So automatically Y3 minus Y2 is also 0. That means the slope is constant, equal. Slope is equal, 0 here. That means it's parallel to x-axis. All y's are same. The line is going like this, horizontal. So they form a collinear set of points. Let us see. Same problem we can do another method. Let Z3 minus Z1 by Z2 minus Z1 be K. Because there is a real number, there is no imaginary portion in this. K is given. See, it is given as K. Z3 minus Z1 by Z2 minus Z1 is real. So let us put a constant real number. K. So when I am simplifying this, what I am getting, Z1 is equal to K Z2 minus Z3 by K minus 1. It is like mx2 minus nx1 by m minus n. It is like dividing Z2 Z3 into a external ratio of K is to 1 or 1 is to K. So dividing Z2 Z3 in the externally, because m1 x2 minus m2 n1 x1 by m minus n. So that means Z1, Z2, Z3 are in same line. Same example is here also. This is also same line. See, if three are collinear only if so this is available such real numbers. A Z1, B Z2 plus C Z3 is 0, and the condition A plus B plus C is 0. These two are almost same. Let us see this problem. So if A1, BZ1, CZ is equal to 0, in place of C, I am putting minus of A plus B. In place of C, I am putting minus of A plus B. So when I am simplifying, what I am getting, Z3 is equal to AZ1 plus BZ2 by A plus B. That means what? M1x1 plus M2x2 by M1 plus M1 is internally, it is dividing. Z3 is dividing Z1, Z2 internally in this ratio of A is to B. So this is nothing but collinear. Same time. Here it is externally dividing, it is internally dividing. Let us see this problem. If Z1, Z2 dash, Z1, Z2 bar, because I don't have a bar, I have put dash here. Z1, Z2 bar plus Z1 bar, Z2 is 0, then show that angle between Z1, Z2 is 90 degree. So let us put x plus iy, Z2 bar is x2 minus iy2. Z2 is x2 iy2, Z1 bar is x1 minus iy1. So I am simplifying on the fundamentals. I am doing this one. So when I simplify this, what I am getting, x1 x2 plus y1 y2 is 0. So when I rearrange y2 by x2 into y1 by x1 is equal to minus 1. It is like slope. Y2 by x2 is Z2 slope. Argand of Z2 tan theta. Y1 by x1 is Z1 slope. M1 M2 is minus 1. That means they are 90 degree. Understood? So we can draw from fundamental, we can draw from assuming a real number, whatever way, we should be able to understand the concept. We know this. This is basically a rule. If mod of Z1 plus mod of Z2 whole square is equal to mod of Z1 mod of Z2, then this is the condition. Z1, Z2 bar plus Z2, Z1 bar is 0. If they are 90 means what? They are 90 means we have seen here. If they are 90, where we have seen? If they are 90, we have seen mod of Z1. Mod of Z1 plus Z2 are gone. Here the opposite side will come. Then they are 90. A square plus B square is equal to C. So in a triangle, A square plus B square is equal to C square. So that is unless it is 90 degree only, it will come. Otherwise, this is mod of Z1, mod of Z2 is more than mod of Z resultant. So there also the condition comes. There also same condition. These are 90 degree. Okay. Now let us see this problem. Prove that this is a form of rhombus. So Z1, Z2, Z3, Z4. So when I find the distances between the points, taking them x1, y1, x2, y2, x3, y3, x4, y4, I'm getting all same conservative item. So either they can represent a square, they can represent a rhombus. So now I'm checking AC and BD. Diagonals, one AC is 136, BD is different. So diagonals are not same. So diagonals are not same, sides are same. That means this is rhombus. If diagonals are also same, then it is a square. This we already see. It is given argument of Z. Means argument of Z is in first quadrant. What do you mean first quadrant? That means Y is positive, X is positive. Y by X is both are positive. If Z minus 3i is 3, prove that cot theta minus 6 by Z is equal to I. This is one of the typical problems of the textbook. So let us see. Let us do it from the fundamentals. Z, let us say X plus Iy. So X plus Iy is equal to R into cos theta plus I sin theta. So I, now this is given Z minus 3i. So X plus I into Y minus 3. Mod of that. So if I am finding mod of that is x square plus y minus 3 whole square is 9. R square is 9. R square. So here 3 square, 3 square, 9 getting cancelled out. It becomes 0. So this is the equation. What I am getting here, R square is equal to 6y. X square plus y square minus 6y. So x square plus y square is equal to 6y. That means R square is equal to 6y. R is equal to 6y by R. 6y by R. One R I have brought it here. So y by R is sin theta. What is y by R? Y by R is sin 6 sin theta. So now let us consider this. R is equal to 6 sin theta. So Z is equal to R into cos theta plus I sin theta. Now I come to this form. This I have used, this condition is used to find out R. I got a mod here. I am finding out what is R here. R is equal to x square plus y square. So R square I am getting 6y. So R is equal to 6 sin theta. So when I am substituting here R value 6 sin theta into cos theta plus I sin theta. So 6 Z comes here, 6 by Z. So 1 by sin theta and cos theta. So when I put conjugate of this, cos theta minus I sin theta by sin theta, that is 1 minus I plus cot theta. So this cot theta goes to the other side. Cot theta minus 6yz is equal to I. See? So here I have used both forms. This form I am forced to use to get my R. This form because the required answer required is in cot theta. So I use fundamental. So here what is the trick is, R square is 6y, R is 6 sin theta. This is the slight thing to be noted so that we can make our work easy. This is calculation part. We are all familiar. This is the trick here. Okay. Now mod of ZW is Z into ZW, that is equal to 1. Argument of Z by W is 90. Find Z bar into W. This is being asked. Okay. So with Z into W, mod of Z W is 1. What is Z bar W? Let us see. This is mod. This is vector. Both are vector multiplication. This is not mod. So what is Z by W? 90 means what? Arc of Z minus arc of W is 90 degree. So that means theta 1 minus theta 2. Theta 1 minus theta 2 is pi by 2. So if you come to here, if I take Z as Z cos theta 1 plus I sin theta 1, W as W into cos theta 2 plus I sin, this is R. or I am representing as mod W, R1, R2, R1 mod Z. So when I am multiplying these two, I am getting Z bar. What is Z bar? Z bar is cos theta 1 minus I sin theta into OW. So R into cos theta 1, cos theta 2 plus sin theta. When I simplify, I am getting 1 into cos theta 2 minus cos theta 1 plus I into sin theta 2 minus sin theta 1. Because we know theta 1 minus theta 2 is pi by 2. So this becomes minus I. So this is 0, cos 90 is 0. So this is minus I. So Z bar into W is minus I. Like that, any given problem, if you look at it in the complex point of view, geometrical point of view, in a graphical point of view, we should be able to correlate and solve the problems.